Ah, sì. Oh, wow. It's already on. Sì? Sì. What? Thank you, no worries. Anytime. Title. Ernesto, devi fare butta dentro. Ok. Vedete voi. Hello, hi there. può spegnere questo? Shall we do it? Right. Is it probably too loud? Am I shouting? Right. Well, let's get started. Wow, this is really happening. Thank you so very much for being here. Well, actually, oh my God, this is last year's slide. Sorry, let me fix that. Thank you very much. 809 times.
Yeah, thank you very much.
Sorry,
yeah, thank you. We have 800 people here.
What are you doing?
I'm doing the opening.
No, we agreed I did the opening.
No, I have the uniform opening. I'm doing the opening.
All right. Well, I have an idea. Let me stay away from the mic. That's a good idea. The other idea is we can share the stage. Actually, we have so many people this year.
Oh yeah, we actually
both.
do have so many people here.
Yeah.
Yeah.
Let's do it together.
I take this off.
Shall we do this game of arms? Yeah, we can do that. Sorry about that. Right. No, I have a better idea actually. Thank you. You're very kind. Let's kick it out. Ernesto, everyone. I have a better idea, actually. I can do the boring parts. You can do the interesting parts.
Oh, cool. I like that.
Let's do that. I just have one thing to say. Last year, there were people complaining, who's this weird guy doing the opening with this very strange English accent? So I said, this year, I can try probably talking like that. So if you want me, I can do this English, and I can probably try it. I'm not entirely sure I can do that, but I probably do. So this is Esther, everyone.
Thank you. Yeah, who is the first time here?
Wow! Thank you.
So many people. Welcome everybody. Hope you're enjoying this conference. Okay, first thing first, we are very proud of our keynoters. We have 4 amazing women and cartoons. We have Avisha, Marlene, Donatella, and Amelie. So we hope that this ballast will inspire more and more people, more and more women to join this field. So yeah, get ready to get inspired and learn and discuss on some remarkable things during these days. Okay, and next, our special guest, Samantha Cristoforetti, this afternoon, 2:45 p.m. We were going to have a question and answer session. Samantha has just landed on Earth right from the start for us, and he's going to join this amazing question and answer. So scan the link there, or remember bit.link pycon-sam.qa, and yeah, start to fill question. I have many questions, so hope you will fill as many as you think. Yeah, that's gonna be amazing. Thank you. And then on Saturday, Saturday, we will have Anna and Alex Martelli talking about, joining remote, talking about what we learned by writing and editing the 4th edition of Python in a nutshell. Didn't know there was a 4th edition?
Yeah, actually.
4th?
Yeah, I started the second, so it's just all there. Yeah.
Okay, okay. Cool. Can't wait. And then this evening there is a special event, Data Beers and Python. So Data Beers is a meetup. We're going to have some lighting talks and of course some beers, but I'm sure there are other alternatives for those like me don't particularly enjoy beer. And scan the QR code. I think there is a limited capacity, so probably it's going to sold out, but check the link, maybe you're lucky. And then on Sunday, we're going to have a Django Girls workshop. They're going to learn how to code a blog. Yeah, that's actually a reminder I had to finish mine, so probably I should join.
Yeah.
But yeah. And then I think.
Ah, boring, yes, no, it's not me. So conference badges. This year we made very clear and explicit on the badges the personal pronouns you want to use, so please be mindful when you're talking to people. You should have selected those. We do have pins on your, thank you very much for showing them. On the registration desk we do have pins, or stickers you can choose in case. And there's also another interesting bit. As you may have noticed, you do have QR codes on your badges. So you can use those to exchange contacts. It's not necessarily for sponsors, it's also for when you're talking to people. So there's only one thing you have to make sure, your profile is public. So if you go PyCon.IT/profile and you switch, make your public profile, you can exchange contact with people very easily and quickly. Connectivity, PyCon.IT is the SID, no password. What can go possibly wrong? And because it's me and our Star Wars meme are never enough, the droids you're looking for is actually Discord, and PyCon.IT/Discord is where we're having all the conversation and the announcements, so please make sure that you're joining Discord. And last but not least, you can actually have a look at all the talks and keynotes live on the website, so PyCon.IT/streaming is the place to be. Q&A sessions will be handled with Slido, or there's a bit.ly link there, or your QR code, Slido-PyCon23 is where you can go and have a selected room that you're attending, and essentially you can post your questions to the speakers. That's what you know.
Cool. So we try to be sustainable as much as we can, and this year we decided to we thought about planting a tree for the conference. And yeah, then we decided that we can do better and plant a florist.
A florist? What's a florist?
Yeah, I think I made it up. It's like a florist and a forest.
Oh, that's brilliant, actually, yeah.
So yeah, we plant a florist.
We plant a florist, right.
Or a forest somewhere in Nepal, and you should receive some communication and emails. And so we plant a tree for each one of you, so that's make 1,000 of you. Yeah. You can actually go there and see your tree growing, so that's amazing.
I named my tree. My name is called Gina.
Wow, I didn't know I should name the tree.
Yeah, you can name your plant. Yeah, you should.
Okay, then we try to be respectful for everyone and make PyCon Italia a respectful environment. So this means lead us to code of conduct. So we have a code of conduct. Please go online and read. But long story short, we try to be respectful of anyone regardless of gender, sexual orientation, body size, race, religion, everything. So we don't tolerate harassment of any kind during this event. And please, if something happens, these are the contacts, but you can contact also on Discord as well, or the yellow shirt. So please, 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 if something happened, report it. See it, say it,
sort it. Yeah. If you don't live in the UK, you probably don't get the joke. This we both do. That's the problem.
Yeah.
Sorry about that.
Sorry.
This is British police train station, isn't it?
Yeah,
Oh,
yeah. Okay, and then we actually from PyCon X we came out from a kind of rule, the PACMA rule. So basically, when you speak, you are in a group, when you have a discussion, try to keep a whole, so to invite the people to join the discussion and don't feel excluded. And then at the registration desk, we have some special pin to express your preference. So we have like happy to socialize or prefer not to talk if you don't want to go involved. And then we have a special pin, red pin with the camera for those who don't want to take photos. So wear it if you don't want, and the photographer will know that you don't want and will not make photos of you. Okay, all the boring stuff.
Yeah, sorry. Yeah. Back to boring. You might have noticed that Ruben's tracks this year are named after Italian dishes, where PyCon Italy, our favorite subject is always food anyway. So just to get your bearings, essentially we do have lasagna, risotto, and spaghetti. We're talking this area. They're all on the ground floor, so they will be divided when it's not keynote time. We also have ricotta and mozzarella, ground floor, like behind us. And we also have rooms, first floor, tigelle, pizza, panino.
I'm hungry.
Oh my God, yeah. Really. I didn't have my breakfast. We also have insalata room, also known as the Green Garden stage. Insalata is salad in Italian, by the way. And the Green Garden is a place where you can have time for yourself. You can want to steam off from the conference, you want to take some time. But we also have wonderful workshops there during the conference. So please check the schedule interestingly.
Cool workshop.
Cool, really cool ones. Yeah. Another thing we really want to say is, as you might have noticed, we're having this year enforcing again the use of face masks. There's a good reason for that. We want the conference to be for the peace of mind of everyone. The space is very limited in this venue, so and room will be presumably packed for all the talks. So we thought that is in respect for everyone. Whenever you're inside rooms, you might wear a face mask. Those will be provided at registration desks, so if you don't have yours, no worries. We have plenty for all of you, so that's exactly the reason. And we also allow a limited number of people standing during the talks, so unfortunately, if the room will be full, there's much we can do. So that's how you have to keep in mind. So if you're really interested in some talks, please make your way to the room in time.
Or watch the streaming.
Or watch the streaming, exactly. We do have, though, although overflow rooms on the first floor. So the rooms on the first floor for keynotes, if the rooms will be packed, you can go upstairs and you can watch directly on streaming, and you can interact with them during the keynotes. As for the lunch options, because, again, there's so many this year and we're so very happy you're all here, we are offering options for lunch. Essentially because otherwise the lunch break would be too long to accommodate everyone in the canteen. So we decided we can have options. We have takeaway boxes. All the options, by the way, are vegetarian and vegan friendly. So you can have alternatives. Yeah, thank you. Again, we want to be as inclusive as possible. We have takeaway boxes you can pick up at the registration desk at the lunchtime. Or we also have a convention with Osteria dei Fiorentini, which is right behind the, right next to the hotel, as soon as you get out of the hotel, and it's totally for free, so you don't have to pay anything. There's no special discount or anything. You just go there, you show your badge, just make sure you're showing the badge.
Collect the ticket at the registration desk.
Oh, okay, you can collect the tickets at the registration desk. On the website, PyCon/lunch, you have all the information, and PyCon/menu Osteria is the menu for the Osteria dei Fiorentini. Last but not least, we organizers, we're not having yet, but we'll
get change.
We'll get change, yeah. We'll get rid of the, how was it, the opening suits, yeah. We have yellow shirts, so please make sure that in case, well, there are plenty over there, there were many volunteers around, so in case of any kind of questions for everything, make sure to check out with yellow shirts. on you. Fun stuff.
Okay, our amazing social events. So we're going to have pie drinks this evening. I think there are still tickets available on the website, so check PyCon social events. And then on Saturday, tomorrow, we can have pie dinner with Fiorentina or vegetarian option, vegan option as well. Check the social events for the venue is close by anyway. So yeah, ooh, excited. And then this year, for the first time, we have guided tours of Florence. So for those who want to take a break during the conference, or if you have a partner that doesn't participate in the conference, has nothing to do, they are organizing tours. There's 10 euros. There's some place available, I think, on the website. So check PyCon.it/guided tour. And then it's the fun stuff.
It's fun.
Yeah.
So that's why I'm doing it. So it's fun starts. Actually, we're not doing it.
Yeah, and then I spotted the data, sorry.
No, I'm not doing it. That's fun.
Yeah, last but not least, if you travel by train, you may have heard of it. There was a special, very damaging flooding in Emilia-Romagna. So for those who don't know the Italian geography, is like the Bologna flat area. That's actually where I come from, nearby. And so there was very, very bad flooding, and people and farmers are very, very in need. So we decided to support the official fundraiser of Emilia-Romagna. So here there is the website. I know it's in Italian, it's the region Italian site. I don't think there is an English language, but check with us with the yellow shirt if you want to make a donation, if you have trouble, and don't ask. Thank you if you do. Really appreciate it. Thank you. And next, we have some acknowledge. We have a grant program, so for those who cannot afford to join the conference, thank you. And this year, we have 94 grants requests, record ever. And it was very, very challenging to select those grants because, unfortunately, we have limited budget. So thank you for our diversity sponsor, EuroPython Foundation, Nefila, and PSF. And yeah, if you want to sponsor next year as a diversity sponsor, yeah, please do. Let's get in contact so we can give grants to more and more people to come.
Thank you. Of course, thank you so very much to our sponsors. This is why the conference is happening. So thank you very much for all your support. It's very, very much appreciated.
And yeah, our partners, our media partners who support us on social media. Thank you. Yeah. That's all, folks. Enjoy the conference.
Actually, there's one little thing I want to say. There's a kind of a surprise, actually. So this is the hidden announcements of the opening. This is the jigsaw puzzle you're seeing. It's a PyCon IT customized jigsaw puzzle, 1,000 pieces. So we decided that this year we want to try sort of a social game, everyone. So after the first keynote, at the registration desk, there will be a bucket. You can pick your piece. We already did, actually some of us did, the border. It's already there. The plan is, if we can get, by the end of the conference, to complete this puzzle, 1,000 pieces again.
Without losing any pieces.
Without losing any pieces.
Without losing.
That's the challenge.
Yeah.
Exactly. So you have to carefully choose yours and keep it as it's really, really precious.
Like gold.
Like gold, or yeah, or whatever. The thing is, if we can all make it, Python Italia Software Foundation next year is going to sponsor 500 euros diversity grant to come to the conference. So this is again for the community. Now, really, that's all?
Yeah, that's really all.
Yeah, we did it.
Thank you, everyone.
Enjoy the conference. Now it's the stage for the first keynote.
Yeah, we should do the stage.
Yeah, it's all yours.
È tuo.
Yes, I should give away the microphone though.
Yeah.
Do you need any of those adapters?
No, I just need HDMI.
HDMI fine. That's it.
Okay.
The mic should work perfectly. You the one does.
I normally would prefer the over ear.
Yeah.
Hello. It seems to work. Yeah, yeah. Hello.
There are 3 seats in front row, so you can, if you are standing, you can come here. It's working? Yeah. So welcome everyone. It's with great pleasure that I present the first keynoter of this edition of PyCon Italia, Carlton Gibson. And his experience as an open source contributor is huge, and especially in the Django ecosystem. So let's welcome him with a big round of applause.
Hello. Good morning, thank you. Good morning. My name's Carlton. This podium's quite high. I should have eaten more vegetables as a kid and see over it, but I'll stand at the side. So, I'm Carlton Gibson, as Paolo said. Thank you for the introduction, Paolo.
just yet. So. Yep, USB-C's in, yep. Do we try the Mac one?
Here.
But it's probably because they just divided the room, so probably the projector are connected to the central room.
Oh, there we go. Something's going on.
Sì, qui non c'è il radiomicrofono, c'è soltanto questo e il gelato. Può fare con questo in realtà, però non so se era previsto.
Okay with this, or
I'm fine with that.
I can seek for a
I'm gonna be standing here anyway. It's okay. I'm not gonna be walking about.
Okay, thanks for.
No, no worries.
I'm gonna.
Okay, HDMI 1. Let's try and read what I gotta go.
Okay. Yeah, that one. You have to switch. Is that the switch? How do you want me to announce it? Aaron Bassett?
Yeah, that's fine. Yeah, that's great. If you want, I have. No, it's fine. I'll do an introduction. It's okay. Don't worry about it. Ooh. Yeah, there's a bio there.
Qui tutta attaccato. Sì. Switch.
Sure. Oh, there we go.
Did it work before with this, or did you have another machine?
Pardon?
Where are you using this machine? There we are.
Yeah, yeah, I can see the two displays up here now.
That's it.
Awesome.
You've lived in Hungary. Sorry, but this is first time I'm seeing you. Did you manage to learn the language?
No, not really. I learned a few words, but
We're neighbors. I'm from Serbia, and it's very difficult.
it is very difficult. All right, so who's up there? What's going on? All right, give me a second.
Have you changed something?
What's right?
Have you changed something? Because I didn't receive the last image from...
No?
I go check now.
If I change something, but yeah, let's just do that. Fine. Oop, hey, where'd it go? There we go. Okay.
When you go full screen, I don't receive the slides.
Oh no.
I don't know why. When you were not in full screen,
You were getting it?
Yes.
So like this? You're getting that?
I don't know why.
If I go this, you don't get it?
No.
Well, maybe.
We have to start if we want to be on time. Can we start? Okay.
Oh, well, that's yes.
Okay, hello everybody. Allow me to present to you Aaron Bassett. He's a recovering software engineer turned award-winning principal developer relations engineer at Parity Technologies. As a developer, public speaker, writer, and mentor, he spends most of his time making cool stuff and helping other people make unbelievably cool stuff. Today, he'll be giving the presentation about Rust for Pythonistas.
Thank you. Never actually heard that read out loud before. That's just like the bio using websites, and now I really need to change it because I'm so freaking mortified. Anyway, yes. Hey everyone, I'm Aaron Bassett. I'm here today to talk to you about Rust for it's just a photo of me. It'll come back hopefully. Yeah, so I'm here to talk to you about Rust for Pythonistas. Until recently, I considered myself solely a Python developer. I'd coded in other languages, but Python was my primary language. I was deeply involved in the Python community. I give talks at Python conferences, including one in this very room in 2018, where I'm going to try and recover my slides. Yeah, go for it.
I forgot something. 1, 2. Yeah, the Q&A session is exclusively via Slido. You have the Slido at the schedule link on the PyCon website. So you enter your question there, and then at the end we're going to read it, and Aaron is going to respond.
If I can find where the frick is Google Chrome went, so here we go. It's up here somewhere. Hey, let's see if we can get back our speaker notes, because that'd be really handy. Okay. Oh, just want to read it. Would that work for everybody? Let's see if we can get these back over here and give you the slides over there. And it's always wonderful being. Is this gonna? Yeah. Okay. It's always wonderful being like the first person up whenever they do the whole room change, because you get to iron out all of the problems for everybody else. I feel like I really am taking one for the team here. So I've been a Python developer for a very, very long time. Regarded myself really as solely a Python developer for much of that time. I've given a lot of talks at Python conferences, including right here in this room in 2018. I'd heard a lot of good things about Rust. Other Python developers have made the move. They told me about like how it was not as buggy, how there was better developer tooling, how there was like C and package management. But I'd been in Python for a while, and I've kind of solved all of those issues for myself already. You know, I had a process that I was familiar with and that worked for me, and I didn't see those as issues anymore. Like, that was all solved problems. Fast forward to recently, where I got approached by a Web3 company. Now, I'll be honest, I was a little bit skeptical at first about joining a Web3 company, as I'm sure a lot of you are when you hear the words Web3 and blockchain. Now, this isn't going to be a talk about blockchain. I'm not going to get into what changed my mind and why I decided to go work for that company. It's enough to say that I did some research into tech, was really impressed, and decided to move there. Now, I wasn't overly concerned by the fact that everything they built was in Rust, even though I didn't know Rust, because I'm a DevRel. Okay, I'm not a core engineer. You know, most of what my job is working with customers and getting them used to using our products and educating them. And it's like demos and example apps and working with SDKs. And everybody everywhere has a Python SDK. I wasn't concerned about that at all. I had in the back of my mind somewhere that I probably would have to learn Rust eventually. But every time I'd sit down to look at some of our codes, well, it looked foreign and unintelligible. And honestly, I was a little bit intimidated. So I'd go and find something else to do. You know, it'd been a very long time since I'd read code that I'd struggled to comprehend. I wasn't used to feeling lost anymore. So I would go and find something else, something I knew, something that was safe. And we're going to look at some examples of code from our SDK, and you can tell me truthfully if you wouldn't have done the same. So I'm going to read exactly what this is here. So these are all code examples from a single module in our code base called Grandpa. And Grandpa stands for Ghost-Based Recursive Ancestor Deriving Prefix Agreement. So what does a Ghost-Based Recursive Ancestor Deriving Prefix Agreement module do? Well, it allows a set of nodes to come to BFT agreement on what is a canonical chain. Okay, I'm lost and I've not even looked at the code yet. Now I'm going to attempt, to the best of my memory, to walk through these examples the same way I did when I was first thinking about learning Rust. We'll start off slow with one of the least complex examples. Okay, so looking at this code, I can probably guess that pubfn means it's a public function. It takes an argument called call. I know enough by typing to guess that our call argument's type is a call object of some sort. No idea what the % is about, or the T in brackets. Looks like our function is going to return a result, more angle brackets. Maybe this means that the result of the function is going to be either a tuple or some sort of error. Then we have an if let. I'm assuming let is for creating variables. Not sure why the if is there. Where did this equivocation proof and key owner proof come from? Are the curlies some kind of spread operator? Does call expand into those? Next example. Awesome. More angle brackets. Love those. So I'm guessing IMPL is for implement. Not sure why it has angle brackets. Does implement take an argument T of type config? Is implementing T? Is palette an argument? Why are there more angle brackets after palette, but with no config this time? Is it the same T that we were seeing in the previous one? And why does some lines have semicolons while other lines don't, and some have semicolons and question marks? Like, I'm starting to get really pretty lost at this point. The last example, and I'm just like, nope, I am out. Like, this is just like incomprehensible, makes no sense at all. And that's basically a speed run of like my first few months looking at that code base of the company. You know, I remember more than one occasion distinctly shouting at my monitor because I couldn't figure out where the fuck do those variables come from. Like, they're not defined anywhere. They're not imported. You're just suddenly appear. Like, why is everything in angle brackets? Like, it just didn't fit into any mental model that I had. So how did I go from being terrified of Rust to kind of loving it? Well, I had a baby. And remember when I said that I wasn't worried about learning Rust because I was DevRel and not like a core engineer? Well, it turns out when your product is a Rust framework for building blockchains, and all of your peers from like the CEO all the way down are Rust developers, and all of your users are Rust developers, and you want to like help your users and be a good asset to your colleagues and be successful in your job so you can keep your job, well, then you need to become a Rust developer too. I like my job, but I really like being able to provide for my kid. Like, keeping your child clothed and fed, it is an incredible motivator. Like, really helps you put aside your fears and prioritize. But I had to stop trying to learn Rust by reading Substrate's codebase. I'll admit, it was humbling, but I needed to go right back to basics. What's chapter 1, page 1 of every programming language book out there? Setting up your development environment. So that's where I started. Now, I am very particular about my Python environment. I often need to have multiple versions of Python running side by side, so I use PyEnv to manage them. Every project gets its own virtual environment, and I never install anything globally. A typical workflow for me is like a PyEnv install whatever version number I need, and PyEnv virtual env version number, start working. Rust up. Rust up install will install the specified version of Rust, or you can do Rust up install stable, Rust up install beta, Rust up install nightly, and it'll give you like the most recent version of each of those channels. Rust up toolchain default, like PyEnv's global will set like a default version of Rust for your environments, or you can use Rust up override set, which will override your default version of Rust for a particular directory. So very similar workflow. Like, this is very close to what I already had set up for Python. Really, really good start. As you probably inferred earlier, I'm also pretty particular about dependency management. I did a whole talk about it back at PyCon UK in 2016, and honestly, not much has changed since then. The main points of the talk was that you should never use pip freeze. Instead, you should add your dependencies to a spec file and then use pip tools to generate out your requirements.txt, which acts a bit like a lock file. Rust has cargo. Your dependencies go in a cargo.toml file, and cargo generates your cargo.lock file for you. You can have dev dependencies, build dependencies, platform-specific dependencies. You can inherit dependencies. You can override dependencies. But you jump on a plane, cargo vendor will download all your remote dependencies in your local directory and even print out like the necessary config changes for your project to start using those local dependencies. Dependency management is hard. Like, I am not one to shit on like Python's dependency management. I know how hard those guys work. You know, I know they get a lot of like flack for it. It is a really, really hard problem. But Cargo's implementation is the best I've seen so far. Like, it took me a long time to find a dependency management workflow I was happy with in Python. But with Cargo, so far, it just kind of works. My projects also tend to lean towards a modular architecture. I work for an edtech company where we white label our content and platform with different publishers around the world. It was all built in Django, and we tailor the platform to best fit the pedagogical standard, that's a fun word, of each country. These customizations made it too complex to have a single multi-tenant deployment of Django. Although, believe me that we tried. Uh-oh. Here we go again. Hey, you got my script again. No, you want this one. Oh. Stop mirroring. Thank you. Appreciate you. There we go. Yeah, so we tried to use a multi-tenant app with Django, couldn't get it to work. Like, there's too many minor differences between things. There was still a lot of shared functionality, so instead we created individual packages for each shared piece of functionality, and each instance then was a pretty basic Django project, a little bit of boilerplate, and a really long requirements file. To make this modular architecture manageable, packages had to follow the same conventions and structure. They had to be easy to edit, publish, deploy. They had to also be well tested, and they had to be well documented. Mark Smith did a 2019 EuroPython talk called "Publish a Perfect Python Package on PyPI." Sorry. Try saying that 10 times fast. It does a great job explaining how to do all of this when creating a Python package. Spoiler, it's really, really complex. You should just use cookie cutter. In Rust, again, it's cargo. Like cargo new will create and you create, cargo test will test it, cargo doc will build your docs, cargo publish will package up your create and publish it to the registry. And if it's a public create, it will also deploy your docs to docs.rs for you automatically as well. Having a consistent coding style is vital in making your projects maintainable. So I worked at a company which is going to remain nameless, and you'll understand why in a second. My colleagues there were very smart people. We had an interesting product, loyal customers, ample investment. Company values were all about like transparency, equity, work-life balance. We had a 4-day working week, no crunch. Like it should have been a dream place to work. I fucking hated it. I dreaded going to work every day. It was the worst place I have ever worked. The original version of your site was written in PHP, okay? This is nothing slating PHP, okay? It just was. That's a fact. I think maybe Drupal. It definitely wasn't designed to be a SaaS product, so they decided they were going to rewrite it in Python. That was field Python rewrite number 1. There was many. So they decided to rewrite in Python, and like most rewrites, it went way over time, way over budget. Eventually, like the BD folks were saying they couldn't wait any longer to list the feature requests from clients, and we had to start pushing out new features. So they decided they were going to stop the rewrite, take the parts that were written in Python, and kind of smush them together with the existing PHP site. So now developers no longer working a rewrite, they can start working new features. But of course, development of these features is taking much longer than they thought it would because, well, things are error prone and things are like difficult, and developers are finding they're having to write the same code twice, once in PHP, once in Python. So they decided the only way to fix this problem was a rewrite. And not just rewrite of the remaining PHP scripts. No, this was going to be a rewrite of everything again. Because the original Python developers who started the first rewrite, well, they'd all burned out and left. And the new developers, well, they're looking at the code and, well, they don't see like the time constraints or the compromises or the feature creep or any of the other factors that influence the code. All they see is bad code. So they decided they're going to rewrite it all again, but properly this time. Yeah, they would repeat this pattern many, many times. I joined in the midst of rewrite number 4. I lasted 8 months, and I saw rewrite number 5 start during that time. Of course, the code base was riddled with technical debt, but you know what I hated most about it? The lack of any consistent coding style. Some code used tabs, some used spaces, sometimes it was 2 spaces, sometimes it was 4 spaces, unless it was a models.py file. They inexplicably used 3 spaces, just those files. Naming was also inconsistent. Some module names were pluralized, some were singular. Variable names would switch between snake and camel case, or if you were very unlucky and had to edit one of James's old files, he had a brief stint with Hungarian notation. The additional cognitive load of constantly adjusting to different coding styles was horrendous. After that experience, the first dependency I add to any Python project is black. First thing, black, installed, done. Second thing, Fleck 8 and like 30 plugins. I lent everything from attribute order in my classes to like function naming. I have VS Code configured to display all linting errors and to format my code and save. I've also pre-commit hooks that ensure that any linting errors or formatting errors can't even get committed. I've become so accustomed to having these tools running that I no longer notice them, which is exactly how it should be. With Black's auto formatting and my editor flagging any linting problems, it is very rare that I have to fix anything before committing. I've become so reliant upon them that I'm way more likely to notice their absence than their presence. Which is probably why it took me so long to notice that my Rust code was also being linted and auto-formatted. As well as Rust Up and Cargo, the Rust community maintains Rust Analyzer, which I installed in my IDE, and then promptly forgotten all about. The fact that it worked seamlessly across all of my projects without any additional configuration floored me. It wasn't just a particular way that I constructed my Python development environment, which made the transition to Rust easier. It was also the way I've been writing my code, or more accurately, the libraries and packages that I've been using in most of my projects. There wasn't a particular moment in time when I decided that I was going to start using type hints throughout my Python code. Instead, it was more of like a gradual progression. A few years ago, I started working with the farm stack, which is like Fast API, React, and MongoDB. Fast API uses Pydantic for its data models, and Pydantic uses Python's type annotations at runtime for data validation. So I began adding type annotations to my code, simply out of necessity. I liked Fast API, and this was the recommended way to use it. At first, I only added the type annotations were strictly necessary, but I began to appreciate their benefits. Not only did it stop me from making silly mistakes, but I also became accustomed to the better autocomplete with my editor. Soon I was becoming annoyed when I would work with code that did not have type annotations. Eventually, I was annotating all my Python code, not just where required for Pydantic. Okay, so I think my development environment was pretty Pythonic, and it just so happened that it was also rusty. Is that the term? Rustonic? Rustic? Rustful? I'm not sure. Anyway, I was pleasantly surprised to discover that the standard Rust development environment felt very familiar to the way I've been working in Python. But what were the high-level differences? Okay, most obvious, Rust is statically typed. And all types must be known at compile time. I thought this would require like adding a lot of additional type annotations to my code. But actually, really, it didn't. The compiler can usually infer what type you want to use based on the value of the variable and how you're using it. I noticed no significant difference in the amount of annotations I needed to use in Rust compared to my Python. In Rust, variables are mutable by default. Not a huge change, but it did make me think more carefully about how each variable be used, forced me to consider every time some data could possibly mutate. The first major difference took some time to click for me was ownership. This is probably the most unique feature of Rust. Ownership is a set of rules which governs how Rust manages memory. It enables Rust to make memory safety guarantees without the need for a garbage collector. Before Rust, all languages familiar with had automatic memory management and garbage collection. Memory allocation was never something I needed to consider. I know there's probably some folks in the audience who've never had to think about it either, so I'm going to do a quick primer on the stack and the heap. Both the stack and the heap are parts of memory available to your code to use at runtime. The stack stores values in the order it gets them and removes the values in the opposite order. Last in, first out. All data stored in the stack must have a known fixed size. Data with an unknown size at compile time or a size that might change must be stored on the heap. When you put data on the heap, you request a certain amount of space. The memory allocator finds an empty spot in the heap just that's big enough, marks it as being in use, and returns a pointer. Because that pointer is a fixed known size, the pointer can go on the stack. Pushing the stack is faster than allocating the heap because the allocator never has to search for a place to store new data. It just gets added to the top. Accessing data in the heap is slower than accessing data in the stack because you have to follow a pointer to get there. Keeping track of what parts of code are using what data on the heap, minimizing the amount of duplicate data on the heap, cleaning up unused data on the heap, and all those other things are all addressed by ownership. I know this sounds complicated, but once you understand ownership, you'll need to think about the stack and heap very often. Lost a lot of time here. There's 3 ownership rules in Rust. Each value in Rust is an owner. There can only be one owner at any time, and when the owner goes out of scope, the value will be dropped. So let's look at an example. A string is made up of 3 parts, which are stored in the stack. A pointer to the contents of the string on the heap, a length, and a capacity. When we assign S1 to S2, the string data on the stack is copied, meaning we take a copy of the pointer, the length, and the capacity. But we do not copy the data on the heap, what the pointer refers to. Okay, so if we don't copy data in the heap, that means that both S1 and S2 are pointing at the same data, and that's breaking rule 2, which means that if S1 and S2 both go out of scope, then they'll both try and free the same memory. To prevent this, we assign S1 to S2. Rust no longer considers S1 as valid. This is referred to as a move. S1 was moved into S2. There's one type of data which doesn't move and instead copied, and that's any data which has a known size at compile time and is therefore stored completely on the stack. Things like integers and booleans. So how does ownership work with functions? It's pretty similar. Here's like a rough example. At the start of our main function, S1 comes into scope. We then pass S1 into text ownership. Its value is moved, and S1 is no longer valid. The sum string value of in-text ownership is not returned, so it goes out of scope and is dropped at the end of the text ownership function. S2 receives ownership of the value of sum string from gives ownership function, and then on the next line, that value of S2 is moved into the takes and gives back function. Now, even though that takes and gives back function returns ownership of some string, the value was moved into the function and then moved back out again, which means that S2 is no longer valid. It lost ownership during those two moves. But in fact, by the end of the main function, only S3 is still valid. So at the end of that function, S3 is going to go out of scope, drop is going to be called, memory will be released. So you can see functions receive and return ownership, but needing a function return ownership every time quickly becomes tedious, which is why Rust has references and borrowing. Okay, the ampersands in the code denote references. A reference refers to the data, but does not own it. And remember rule 3 of ownership, the value is only dropped when the owner goes out of scope. When functions have references as parameters instead of the actual values, we don't need to return the values to give back ownership, because the function never owns the value. We call the action of creating a reference borrowing. As in real life, if a person owns something, you can borrow it from them, but when you're done, you have to give it back. You don't own it. Also, you can't modify what you've borrowed, at least not without getting the owner's permission. Like variables, references are immutable by default. If you want to give the borrower permission to change the value, then you need to use a mutable reference. So I have some last examples. We're going to try and run through them really quickly. This is a struct. You can define methods and structs. Methods must have a parameter named self of type self as the first parameter. Does this look like anything to some people? Recognize this? Very similar syntax. Rust also has enums. Enums are actually one of my favorite things of Rust, because enums give you a way of saying a value is one of a possible set of values, which is incredibly useful when combined with things like match the control flow. It also has a couple of built-in enums. One is option. Option in code is a very common scenario in which a value could be something or it could be nothing. This is actually incredibly useful. Another enum is result. Result variants are OK and error. Similar to option, OK variant indicates the operation is successful, and inside OK is a successfully generated value. While the error variant means the operation failed, and error contains information about how or why it failed. So why are these my favorite parts of Rust? Like, couldn't you just kind of do it with some if statements? Well, match has an exhaustiveness requirement, which means that if you're matching on an enum, you must handle all possible variants. Add a new variant to an enum, but forget to update your match to handle it, you'll get a compiler error. Your code won't compile. Having a function return or accept an option ensures that you must at least consider that the value could possibly be none when writing code which interacts with an option. And if a function returns a result, but the caller does not handle the error, your application again will not compile. It does all these things to try and help you from shooting yourself in the foot. This doesn't mean that your Rust code needs to be horribly verbose. There is like a catch-all that you can use in match. You can supply defaults to option with like unwrap or and a bunch of other kind of like helper functions. And you don't even need to handle every error being returned as a result and where it's being raised. You can use propagate to let it bubble up and catch it higher up the stack. There's a lot more to Rust, more than I have time to cover here because we're at 25 minutes. But there's one last thing I want to talk about, and that is, what the fuck is T? Like, we saw a bunch in the substrate example at the start, or more recently with like option and result, but what is it? So T is a generic and abstract stand-in for concrete type or other property. Take something like these two functions. They're almost identical. So let's swap out the concrete type with a generic. Now the function is generic over some type T. It has one parameter named list, which is a slice of values of the same type T, and it will return a reference value which is also the same type T. Now, for reasons this code won't compile, because Rust knows how to compare things like integers or characters, but T can be any type. So how, if you had like a country type, for example, like how would you judge what's the largest country? How do you decide, is it like by area, by population, by like GDPR, or no, sorry, GDPR is privacy, not like GDP, by exports. Like there's so many different things you could judge the largest country by. Like there's no way it would know how to judge every single type. This is where traits come in. I'm about to get my hand over here. But the compiler does tell us how we can solve some of these errors as well. It's saying here that we can restrict what types T can stand in for by specifying the type T must have the trait of standard, compare, partial ordering. A trait defines functionality a particular type has and can share with other types. The partial ORD trait can use methods for ordering, less than, greater than, and so on. The standard library implements this for like a bunch of different built-in types, integers, cars, etc. But you can also implement it for your own types as well. So if you decided that, okay, we want to order countries based upon population, you could write your own traits for that. And then your largest function would accept those traits, or sorry, would accept those types because it had the correct type and it would be able to be ordered. So I'm going to call it there because we're already 2 minutes over. And one more minute? Oh, awesome. Great. Okay. So we're going to skip right through this stuff, which is more about traits and bounded traits. So bounded traits are quite interesting. Here we have a notify function, and it's saying that it can take a T, which is generic, but it's saying that T must implement the summary trait. So if we look at the code there, we have this item.summarize. The summarize method is part of the summary trait. So notify needs to know that whatever object it is receiving will have that summarize method. How does this relate to like the stuff we saw earlier? Well, sometimes, sometimes a function can have lots of like the trait boundaries. So many, in fact, that we can go back to like terrifying subject example again. And now we know a little bit more about it, which we didn't really cover too much, so bear with me. So if we're looking at this now, we can see that it's an implementation block with the generic types T, R, P, and L. Okay, that's those T, R, P, and L are just generics. It's got an offense report system as a trait, and it's been implemented for specific types as well. Okay, it's been implemented for 2 types, option and a tuple. The for equivocation report system tells us the implementation block applies the equivocation report system that's parameterized with those generic types, the T, R, P, and L. And we can look and see what the T, R, P, and L is down in the where statement, where we'll see like things like P can be any object that implements the key owner proof system and is associated with type identification tuple, which should also be clonable, and so on and so on and so on. Okay, still not the most readable thing in the world. Hopefully, yeah, we're gonna time out. Most of us couldn't like this. I just want to put up these links for people as somewhere you can go and look into this a little bit deeper. Sorry we ran out of time with some of the technical issues there, but do we have time for questions?
Yeah, we're going to take two or
Awesome.
3 questions. So first question is, have you ever tried binding Rust code to Python using PyO3?
I have not as of yet. I have to admit that because of what I currently do, my Rust is very much just Rust.
All right, second question. You've mentioned that Python and Rust packaging. Now we hear a lot about Rust integration to Python. How would you package a project that has both Python and Rust?
Again, I wouldn't, unfortunately. Everything I do these days is 100% Rust. The only thing I might be moving slightly into is that we do use Rust to build out WASM, which is what a lot of the stuff we run on, or everything we build kind of actually is executing. So I may start to look more back into Python again when WASM support becomes a little better.
Okay, there were a couple more questions, but we don't have any time, unfortunately, so please, big round of applause
for the rest of the day. Come say hi. Oh, it's okay. I had like the timing down to like 25 perfect, and then with the bits I just lost some. Yeah. I kind of got it mic'd up with like Web3 stuff, Yes.
Yes, I've also been there. I saw the logo.
Yeah, we were a sponsor last year, I think, and probably again this year. This year was ready.
Yeah, next year.
Next year. Oh no, it's Euro Rust is what's coming up, isn't it?
Yeah.
I did not make it to it, unfortunately. I had a clash with again, I'm going to have a clash in Euro Rust as well, but...
You mentioned these couple of first times when we tried to read the code. It's exactly the process that I was going through. So how much time?
I had a really tight time constraint on it. So as part of my job, basically do this thing called the Code Up Blockchain Academy, which is where we hire a lot of people from. So basically went like, you have to get into the academy, you have to pass one to your job.
I think you probably said
Again, the academy does pass the rest test.
Yeah, absolutely. Because I forgot that we only have a standing microphone right now in this room. No,
But it was enough to get
or something. Is that
to
okay?
the
So
point
you
where
need
I
to
could pass
stay
the-
here. Yeah, I can ask if we can find some.
But really, all I did
would be
was
comfortable with that.
don't worry. Okay, it's fine. Brown University has a version of the Rust book, like the Rust language book. They have a version of it online, which has exercises in each chapter. So as you're like reading the content, they'll then test you on what you just read. So you can test your own understanding of the. It's a great resource. I'll get out of your way.
Questions as well, but I'll try to catch you.
Sure. Yeah, I'll be floating about.
Seems to. It's very short, whatever you prefer. Giovanni. Yes.
Why are you preparing? Because Rust is here many times. Rust is kind of a modern, replacement for C++. But I never tried Rust. I write if I need a real time, so I do the C or C++, which I bind if needed to Python.
So, I mean, the real advantage for, at least for me, against like, I mean, it's writing Python extension is that compared to C and Python, it's, I mean, you write so much less code compared to less code. So that's I think that's the number one advantage of that.
That's how I told me to do Python. So if you write the extension like that, because if I write like a C extension or in a C++, I can build a short library which I can use however I want. For Python, it can just be a cycle.
If you use the PyU3 library, which is the one you use to make Python extension, you can PyU3, yes. You can with the same build make both, let's say, the Python extension shared library.
Similar to the Swift and
exactly, and but at the same time you can also make like the standard library if you also expose interfaces. So yes. Oh, jeez. but it resets the fantastic. Good to know.
He's a physicist, software developer, and a site reliability engineer. He's passionate about photography and in love with radical honesty. Today he's going to be giving us the talk about the Granian, which is a Rust HTTP server for Python applications. Also, please ask your questions in Slido. There is the link for Slido in the official website of PyCon under the schedule and then for this particular talk. So enter the questions there, they're gonna get moderated and then we'll discuss them at the end. Please go ahead.
Ciao PyCon Italy! So, yes, this morning is a bit rusty in PyCon Italy. It's nice to see it. So, who am I before beginning? I'm Joe. I use Python like since 2010, something like that. I mainly code as a web developer, and I'm currently infrastructure engineer, so I also do quite a lot of stuff like on that side of the spectrum. I'm an open source contributor, like for 10 years or something. Yeah, and that's it practically. So, what is Granian? As the title suggests, is an HTTP server for Python application. It implements at the moment HTTP 1.1 and HTTP 2 protocols. It does SSL termination, it supports WebSockets, and it supports several, let's say, application protocols. We will see in detail what does this mean. And what about the name? So for the one of you that are not like Harry Potter fans, it's like a creature from Harry Potter. Why such a name? Just because, you know, it seems that all the servers has like creatures name, like unicorns and that kind of stuff. So I said, whatever, okay, let's pick a name which is comparable. So, the big elephant in the room. Why does Granian exist? Because as someone pointed out on Hacker News, apparently there is no need since Python has already an HTTP server. Thank you for noting me that. But I mean, more seriously, it's a good question. There are already some options out there, so it's not necessarily immediate to build a new HTTP server. So to explain that, I want to go a bit back in time. So let's say that unless you've been living under like a rock in the last, I don't know, 8 years or something, we started switching web development in Python from a synchronous paradigm with WSGI to asynchronous paradigms. So I think ASGI is the first draft is from 2015, something like that. But yes, so we ended up creating, like, let's say, a new application protocol to support the async and wait flow, etc. And that's one of the reasons why Granian exists. Because in 2021, couple of years ago, so the available servers, at least the ones I knew of, were Daphne, which is the original, let's say, server implementation made by the Django community, which is also like the reference of the starting reference for the ASGI protocol. Daphne, I mean, it's actually nice because it supports HTTP2 since like quite a long time. But in my experience, let's say that it doesn't really play well with high concurrency. It doesn't really support like multiprocessing, several threads, stuff like that, at least that I know of. There is UVcorn, which is the most popular solution, let's say, for ASGI applications. The nice thing about UVcorn is that it has like Cython, let's say, library to parse the HTTP request, so it's quite performant. The downside is that it doesn't support HTTP2 or unless you write a protocol for that. And then there is Hypercorn. It's like the youngest of the three, and I mean it is a really nice, let's say, piece of software because it's the only existing HTTP server for Python application which supports HTTP3 actually. On the other side, let's say that the performance of Hypercorn, at least from benchmarks around, is not like very good. So that was the, let's say, the context in which I started reasoning about HTTP servers in Python. And in addition to that, I also maintain a web framework, which is called Emmet, not super famous. But I really wanted to support HTTP2. So actually, in Emmet, since end fall 2020, I wrote, let's say, a custom HTTP protocol for UVcorn based on the H2 library. But the final result wasn't really compelling. I mean, it suffered like a lot for performance issues. It was not even very correct implementation because, I mean, HTTP2, it's quite hard compared to the version 1 because you have streams and you need to handle like quite a lot of stuff in concurrency. It wasn't easy. The solution wasn't really good. And in the end, it seemed like I need to choose between having like all the features I wanted or having the performance I like to have. And that's where the idea came to maybe find a different, let's say, way of handling HTTP requests in Python. And at the same time as I was starting like learning Rust, so let's say that the two things came together at a certain point. And I also in Rust found like a very good library for working with HTTP, which is named Hyper. And so I said, you know, why not? Let's try. And so the final rationales on why Granian exists are this one. So to have, let's say, a single correct HTTP implementation regardless of the version, to have a single package that is working on, let's say, the same way on all the platforms. I don't know how many of you needed to run servers on Windows, but in general, let's say, it's like a different story. And also, one thing I always disliked is like you need to put together several packages to run your application. So let's say you use UVcorn, but you add the HTTP tools optimization, and you also maybe want to add Unicorn to have like, I don't know, workers management, etc., etc. My point was to have also a solution that was deployable like on the edge. Let's say I don't know, I have very few hardware resources, I don't want a proxy server or whatever, so I can just deploy it on the end. And all of this with, let's say, comparable performances on the existing solutions. Because, again, when I started, it was like, I'm learning Rust, I have an idea, let's see how it plays. So how Granian is actually built. To see that, the starting point is the event loop. Because let's say that in the asynchronous, let's say, world, every HTTP server actually uses the event loop, let's say, primary function to listen to TCP sockets or stuff like that. So a typical, let's say, Python asynchronous servers is actually something which runs infinitely on the Python event loop. And so every, let's say, step of the request are run as coroutines over the loop. So like the listening of the TCP socket, the processing of the request, the run of your actual application code, the streaming of the response, etc., etc. And what UVcorn does with HTTP tools is actually use C to optimize a very specific part, let's say, of this flow, which is the request parsing. But I mean, the logic is still the ones you saw. So everything is run through Python code. There are some C optimization in the CPython library, etc., but let's say everything runs on your main thread in Python. And so Granian is a bit different because actually the things we saw are actually run into Rust. So there's the Rust Tokyo runtime, which is comparable to the Python event loop, which handles, let's say, everything, but let's say your application code. So when you run your application with Granian, you actually have two different event loops, and the Rust ones schedule, let's say, tasks to run on the Python one, which the only thing that does at that point is running your application code. So let's say that the major difference here is that there is no Python code involved at all except the ones you wrote in your application. All the threading and stuff is handled by Rust itself. So I like to say that everything is like offloaded from Python to Rust, everything that is not written by you. How this is made? With the tons of actually good libraries. So there's the Tokyo runtime, which is the comparable thing to the event loop. There is Hyper for HTTP, Tungstenite for WebSockets, and PyE3, which is the, let's say, #1 library you want to use when you need to talk with the Python interpreter and stuff like that to make extensions. There's also an async.io package for PyE3, which lets you make every communication asynchronous, even between Python and Rust, or eventually, I don't know, sending awaitables to Python or awaiting Rust futures from Python and stuff like that. And it eventually gets back, I hope. Wow, nice color. Okay. I hope you guys like green. Maybe I just, let's see. Old trick. Hello? Still green? I hope you guys like green. So, just briefly, this is just some weird looking code. Is just to let you know how does it look like. Let's go to the main topic here, right? But before showing you the numbers, I want to make a couple of, let's say, warnings. The first one is that the aim of this benchmark is not to, let's say, stating that Granian is superior to UVcorn or stuff like that. It's not about putting UVcorn in a bad light. In fact, UVcorn and Granian are so different in the architecture that it's kind of like comparing apples and oranges. I mean, the purpose they do is the same, but they're so different that just keep that in mind, okay? It's not about saying what is the best. Again. Hello, buddy? Are you there? I would talk, but actually it was the moment of the charts, so I can.
looks like the adapter has maybe like a malfunction or not. So sorry about that. Yeah, I think the adapter is. Wait, yeah, the adapter.
Okay, okay. Okay, we're back. So, first chart. So, a very simple benchmark. This is like plain text, I think 4 bytes response across like Granian, UVcorn, both with HTTP tools optimization and the standard, let's say, package, and Hypercorn. These are proprietary benchmark, meaning run on my machine, single process, so to not, let's say, make assumption based on concurrency, just a single process, that's the result. There's also some external benchmarks. These are run by Tech and Power. There is a benchmark suite that gets continuously run with tons of frameworks. Yeah, this is also with the JSON response to enlighten, let's say, the CPU bound usage. So the results, it's kind of 5.7 times UVcorn without anything, and from 25 to 47% performance increase over UVcorn with HTTP tools. WebSockets. So WebSockets, let's say that with a single process, you can expect something like 80% more concurrency increase over UVcorn. Those are messages per second processed by the server. And the resource usage, which is one of the point actually, because instead of having Python running everything, you actually rely on Rust. I don't still have, let's say, proper numbers because the project is actually quite young. I mean, the first version release of Granian is from November last year, so I still have to collect data. So from, let's say, some tests in my company and software like that, there's a 10% increase in RAM usage on a tiny application, like the base is 65, so you can expect something like 70, 72. And major reduction in CPU usage on the average. The numbers we saw on a couple of services with ASGI protocol is kind of like that. What about HTTP2? So HTTP2 is very hard to benchmark, so I don't have proper numbers here as well. But let's say that from the preliminary tests, you can expect like 6 times the performance of Hypercorn. But there is still a but here. And the but is that ASGI is designed to be run on Python. So I ended up designing a new application protocol. And to quote XKCD, I know that every time someone invents a new standard is like, yeah, there's just another standard. But let me say about the issues I found in supporting ASGI protocol in Rust code. The first thing is that ASGI is all about events. So the server and the application speaks with these dictionaries, which contain like some preset of keys, like the type of event that is happening. And so this ends up usually having like quite a lot of if statements on the protocol side, let's say, of the server. And the other thing is that not actually all the events are doing I/O. So the interface is the same. So the send, let's say, coroutine you speak with is unawaitable. So of course you need to await. But in this example, when you send a response, via HTTP in ASGI, you have two calls to make. The first is about headers and status code. And that call actually doesn't need to be asynchronous. So that means that you are actually putting into the loop something that doesn't really need to have all that machinery. So I invented the RSGI, of course, because it's Rust Server Gateway Interface. So the idea is actually to have a single protocol object with several methods. And it works. I mean, I think that the interface is quite solid at the moment. But the advantage of this is that actually it gives like a lot of performance on the results, because on top of Granian being faster on ASGI, it could actually be even faster with a different, let's say, protocol implementation. And another good thing about RSGI is that it can offload the static file serving. So if you have static file like CSS, whatever. And this is pretty good. This is a test I ran on Emmet, so the framework I also maintain. The 2.4 version was using UVcorn with HTTP tools. The 2.5 uses Granian in RSGI, and it makes like 28 times faster serving of static files. So that's very cool. A big warning here. So RSGI is not intended, because some people ask to me like, explain me why you need a new protocol, but it's not targeting like actual developers. Okay, so in the same way, when you build web application, you don't actually think about ASGI because it's behind the framework you use. The target audience for our SGI is actually framework developers. So if Starlet like to implement the RSGI interface, you can use it on Fast API for free. What about WSGI? Yes, I have it as well. So actually the code is even simpler because you don't have the Python event loop running. So it kind of behaves like Gunicorn with greenlets. And if you want to use with WSGI, please wait the next version, because at the moment it doesn't actually iterate the response body. So if you're streaming like large bodies, don't do that. And the performance is like comparable. Like 4% increase doesn't really matter. Does it scale? Just to close it. I don't know. I don't know. I mean, using multiple threads, etc., doesn't really seems to make a big difference. Just quickly to close it up, what I learned from all of this, Rust is actually fun. It's quite simpler to write Python extension compared to C and Python. It has an impressive community, like the cargo and packages and support, it's awesome. PyO3 is super quick to learn. And just a few months got me having this performance, so nice. It's also hard. If you saw the previous talk, there are some things that are not so easy from a Python point of view. Writing performant code is like art. You need to take a lot of decisions that you actually usually don't care. Threading is super hard. Even my assumption, so I assume to gain performance by leaving multi-threading on the Rust side, but actually it seems to not make such a difference because probably, I don't know, the GIL or something, and I don't really know. Async IO and internals are like a mess. There's a lot of objects, like you have handles, futures, tasks. The magic behind the await statement is like huge. Context vars, it's dark magic. 0.4 of Granian is yanked actually as a release. You need to use 0.042 because 040 leaked context, because yeah, I didn't understood so well how context var was working. And FFI and CPython internals are not required, but probably it's nice to know them. That's it.
All right. Thank you. Yeah, I'm sorry to have to cut you off, but like we had the problems and everything. I'll read the questions that got the most votes. So there are there any performance issues on marshalling serialization or deserialization between Rust and Python structures?
So you have a bit of overhead in converting, let's say, bytes and strings to and from let's say Rust, but since Pyo 3 relies on FFI, it's not so much, at least from the numbers. Let's say that's not the problematic part about performance.
The second question, does Granian support request timeouts? Can it kill a thread that has been processing a request for more than, for example, 1 minute?
Not really. That's usually left on the framework, let's say, implementation that uses Granian. On this, I just want to add that since you have two different loops, you cannot actually block the Rust one, because when it runs like the actual Python code, you cannot like block the other one.
How does Granian compare to Robin?
So I think that the behind the scene is quite similar, because Robin uses Sactix behind it, which uses Hyper behind the scene. But the scope is very different because Granian is not like a framework. So it's just about giving you a server implementation you can use on your application. It doesn't force you to use a specific, let's say, framework language to building your application.
Okay, thank you so much. Please catch the speaker in the calls and ask him other questions. Thank you so much.
Thank you very much.
To try something out with the adapter, or do you
and stuff?
Oh, we might. Yeah, but there might be. Find you and I'll start. Hello everybody. Allow me to present to you Sanskar. He's a software engineer at Bloomberg and a FOSS maintainer. Today he's going to give us a presentation about Robin. So please begin. Sorry, I would just like to remind you, ask your questions at Slido. There is the link at the official website under schedule. I always forget to say that one. So ask the questions there. We're going to moderate them and then ask at the end at the Q&A session.
Hi everyone. First of all, thank you for coming to my talk. I know I stand between you and the most important part of the day, the lunch, but I will ensure that this talk serves as an appetizer for the feast that awaits us. Okay, so a quick introduction for me. My name is Sanskar. In the mornings, I work as a software engineer at Bloomberg, and during the nights, I maintain free and open source software, and one of them is Robin. Speaking of Robin, we come to the question, what is Robin? Simply put, Robin is a fast async Python web framework with a Rust runtime. But before we dive any deeper, I'd like to tell you a story, the Robin story. So once upon a time, in the vibrant month of April 2021, there was a university student who was overwhelmed, and his name was Sanskar. He was in the final year of his university, and he was supposed to submit a project. But like all diligent university students, he spent all his time scrolling Reddit. During that time, a major company decided to adopt Rust into their codebase, and Reddit was filled with memes about rewriting everything in Rust. And I, at that time, was an avid Flask user, and I was annoyed that Flask lacked async support back then. I had tried Quad and Fast API, but they didn't have much developer adoption back then. So, scrolling Reddit, one fateful day, I got this epiphany. I asked myself, why not create Flask with async support? And then, you know what would make it cooler? If it was written in Rust, of course. And this is how Robin was born. But let's come to the most important question of the talk. Why the name Robin? Because I thought to myself that if I take care of an entity called Robin, if I nurture it and develop it, that would automatically make me Batman. So if for some reason I am not responding to you, just have a bad signal beside you, and I have a moral obligation to come back to you. And since its inception, Robin is hosted on GitHub, is housed under a BSD 2.0 clause, is currently at version 0.31.0, is more than 2,600 stars on GitHub, has more than 750,000 installs on PyPI, but most importantly, it's under active development. And over time, we have acquired some sponsors, and I'm really thankful for them. But most importantly, a project that was started as a single-person project has more than 40 contributors. Yeah. You may see some familiar faces here, and that's incredible. But I'm pretty sure at this point, some people must have had this question: why another framework? The ecosystem is flooded with so many web frameworks. Why do we need another one? But before I answer this, I'd like to tell you the comparison framework that I use to judge the framework available in the market. So performance is important for me. Then comes the ease of use, then scalability, built-in features, extensibility, and a term that I coined myself, it's hacker or innovator friendliness, and then the end-to-end application timeline, and most importantly, the community. If we choose a current framework in the market, I believe that we have to settle in some aspect for that. If the performance is there, then the ease of use suffers. If it's scalable, then the built-in features might not be there. Or if the built-in features will be there, it's too opinionated to be extensible. And I believe that we have been talking about scalability a lot, but we do not focus anything on hacker friendliness, which I believe should be improved. And community is pretty nice for most of the frameworks, thanks to you all. And end-to-end application timeline is decent, but I believe can be improved. So my target with Robin is to create a framework that excels in all of them. It's not there at this point, but we get there. So a summary of Robin would be a fast-pacing Python web framework with a Rust runtime. But a detailed explanation would be it's a high-performance, community-driven, and an innovator-friendly web framework. Now, speaking of performance, I will let metrics do the talking. And according to Tech Empowered, Robin can serve over 1 million requests per minute, and we are only getting started. And let's have a look at the architecture to have a sense of why it is so much faster than all the other frameworks. First of all, we have a Rust core. This is the majority of what makes Robin faster than all its competitors. We have a multi-threaded runtime that's backed by Tokyo. This part allows us to use real Unix threads and bypass the guild at various places. Then we have a worker event cycle that does all the dirty work for us. So this part manages the runtime, passes all the instruction to the Rust code. This part also initializes the thread pool and routes all the incoming requests to the threadsafe router. And finally, when we start the app with the Python app.py command, the Python code is converted to Rust objects, as you can see there. And then the router is populated, incoming requests hit the router, and depending on the type of request and the type of function that we have to execute, be it a synchronous function, an asynchronous function, the request is dispatched into the threads, and finally the completed tasks are sent back to the worker event cycle. Pretty cool, right? Now imagine it being way faster. So Robin not only allows for multiple workers, but it also allows for multiple processes. We have a shared TCP socket that not only allows you to use the threads of your processor, but also the number of processors that are available in your system. So how would you configure that? You would specify the number of processes that you require and the number of workers that you require, and it's as simple as that. Now, let's talk about the ease of use. I believe that if a framework or a tool is not easy for us to use, we won't bother learning it. As software engineers, I believe we solve some hard problems and some very hard problems. And if a tool is adding to it rather than subtracting from it, I don't think it's any fun to use that tool. So let's have a look at the generic Python app lifecycle. We have a reverse proxy, usually something like Caddy, Nginx. Then we have a web server, a WSGI, an ASCII, or maybe RSGI at some point. And then we have a web framework like Flask, Django, FastAPI, and so on. Let us have a look at the framework side of things. A quick question to the audience. How many of us know how to write a generic Flask application? Wow, so that's like 90% of the room. So it is precisely for that reason Robin looks like this. I loved writing Flask applications, and I knew many people liked Flask applications as well. So making Robin after the Flask API was almost a no-brainer. So if you folks know how to write Flask application, writing Robin would be almost no learning curve. There are a few differences that I believe could improve the developer experience, but should be a very low learning curve. However, let us talk about something that sparked a lot of controversy when I launched Robin. Something that wasn't a no-brainer, the web server side of things. Traditionally, you would either have a web server gateway interface or an ASGI. These SGIs were created to set a standard. So this allowed the framework developers to expose some interfaces and the server developers to consume from some interfaces. So making the collaboration between the framework developers and the server developers very easy. But, so this was pretty nice because the framework developers didn't have to worry about managing the HTTP side of things, and the server developers didn't have to worry about the routing. So this was very nice. However, in Robin, there is no SGI. You do not need one. A server is coupled, built in with Robin, and that is one of the reasons why Robin is way faster than its competitors. However, when I tell this to someone, their usual response is, what about PEP 333? Or what about ASGI? My answer is that if you read the PEP carefully, you would realize that it was supposed to make the collaboration between the framework developers and the server developers easier. But in our case, we are handling it for you, so you do not need to worry about that. So when you want to deploy a Robin app, you just need to configure a reverse proxy, and the server and the framework side of things are handled by us. Now, let's talk about scalability. I like to split scalability into two parts. One is the performance at scale, and the second is how we structure our code when the code base grows. So we have already talked about the performance at scale. We have a reverse proxy, and the server will handle the performance for you, as seen in the benchmarks. Now let's talk about the organization. Robin supports views for organization of code, and making all the responsible code snippets in a single function. So if you look carefully, Robin supports functional views at this point, which I believe is not available in any other framework. I like to structure my code in closures at some point, but I couldn't do that in anything else. But class views will be coming soon, because I know some people like classes as well. And sometimes views are just not enough, so Robin also supports routers. I'm pretty sure most of you must have used routers at this point. So you just create a sub-Robin app included in some other file, and then you can define your code base like this. Now, let's talk about the built-in features that Robin houses by default. These are important in my opinion because built-in features serve as a solid foundation of a framework, and you should do these things correctly before you move on to other things. Also, if there are no good built-in features, I'd have to implement everything myself, which kills the point of using a framework. So Robin supports synchronous functions, Robin supports asynchronous functions, directory serving, static file serving, URL routing and path parameters, middlewares, and application events. So now let's talk about extensibility. This topic is very close to my heart because I am a person who wrote a custom code editor for myself. So extensibility, just having the ability to extend the structure or a framework made me feel very empowered. So for that reason, Robin supports extensions. So how would you install an extension? You just use the square bracket notation, specify the type of extension that you'd want to use. So for example, we have templates. We support Jinja templates by default. So if you want to install templating, you do pip install Robin templating, and then you can consume the Jinja template. However, if you decide that you do not like Jinja templates, you want a custom template renderer, you can just consume the interface, override it yourself, and use any other templating engine that you'd like. Now, should you decide that you require an internal GraphQL application and you want a REST application for the client-facing, however, a GraphQL application for internal-facing, we support Strawberry and GraphQL. So you'd create some Strawberry types, and then you'll declare it, and you can use this Robin GraphQL extension to have an internal GraphQL application. Yep. So coming to the hacker friendliness side of things, I'd like to talk about this a bit in detail. I am a very strong proponent of frameworks being hacker friendly. At this point, I believe that in the framework side of things, we are talking about type safety, runtime data validation, but things that were supposed to make large teams collaborate easier. However, we forget that the apps that we talk about were created by 1 or 2 people who just pulled in an all-nighter, caffeinated themselves, wrote maybe terrible code in retrospect, but it is the reasons that these apps exist. So I believe that a framework should also allow quick prototyping or quick development of an application. And Robin, for that reason, has a unique feature called const request. So what a const request is. So we just talked about the Robin architecture at this point. And I realized that this part of the code is very global interpreter log dependent. Maybe we could create some optimization where we could pre-compute the response and store it. And this part would be useful when we were serving JSON payloads or serving an image, serving static files, where we do not need to invoke the GIL continuously. So const request basically computes the response in the router and then serves it back to you. So the GIL is not required at this point, and the serving is way faster. Many people would like to call it caching, but you do not see a TTL here, so I'd like to call it const request. So how you would use it is you'd specify a const equals to true flag in the route declaration, and you're good to go. And we have WebSockets. Most of us are aware what WebSockets are. So we have WebSocket methods, so on message, on close, and on connect, and you declare it like you would declare a certain router. And finally, not needing to choose a server, I sometimes got fed up by the paradox of choice that was available with choosing a server. We had GUnicon, we had Starlet, we have Uvicon. So Robin comes with a server built in, so you do not need to worry about choosing that. Just a simple command like you would run any Python application, specify the workers, the number of processes, and you're good to go. Okay. Now, let's talk about the end-to-end app creation timeline. I created this term. It basically represents the time required for you to start an application from scratch and get it up and running. So what you would do is you would install Robin through pip or conda, and then we have something called Robin CLI. So backend development these days, in my opinion, is not just as simple as writing a Python application right now. We now need to worry about creating a Docker file. We need to worry about configuring the reverse proxy. So Robin CLI will allow you to have a single flag called create. Will ask you if you require Dockerization, if you require any reverse proxy. And with the simple prompts, you can configure it for you. And also, it will start a basic route for you. So you have a basic Hello World app that you can easily deploy. And if you believe that you're in the zone and you do not want to go outside, you can just have the docs flag, and it will open up the docs for you. At this point, we just open the online docs for you, but at some point in this year, we will have offline docs that will be viewable in the terminal. And you can easily run it in production. You just specify the workers and the processors, and you're basically good to go. Now, coming to the most important part, the community side of things. And before we end this talk, I'd like to tell you another story, the community story. The Robin community started like how many other amazing things start, with a post on Reddit. Okay. Oh. Looks like the Reddit servers crashed it. Yep. So I started a Jitter channel because it was cool to interact with the... Okay. Let's try again. That's not right. Maybe third's the charm. Okay, yeah. So we started a Jitter channel because we enjoyed. Okay. Bear with me, just a few technical faults, I guess. Let's maybe this will work. I see. It's not working.
Yeah.
No worries.
Try, direct access maybe.
Maybe this will work. No.
Yeah, remove that. Maybe dancing like that.
Okay. Maybe I'll hold it for a while.
No, it's just wiggling.
It's the other rooms as well. Again.
Or
So
maybe I can continue without the slides.
yeah, I think you should because I'm a matter of time.
Yeah, okay. I'll just narrate the story without the slides. Oh, okay.
That's it.
Okay, no worries. I'll narrate the story without the slides then. So it started out like how many other amazing things start with the Reddit post, and then we created a Jitter channel. Eventually, we moved to Discord because we believed that it was more accessible. Yes. But come November 2022, and life got a bit overwhelming due to some personal events in my life, and I couldn't devote as much time as I was devoting to Robin. Then I had a surprising observation. We still made progress during that time. So if we have a look at our commit chart, we see that the community members were driving Robin at that point. I was still reviewing it and writing some code, but the community was driving it. So we can see the progress that was made during that particular month. So I come to this realization that the community was growing at a steady state. Many features were recommended by the community. 60% of the releases had community involvement, and the 4 out of the past 10 releases didn't require any involvement from me, and I believe that was incredible. So just having Robin under my org doesn't feel nice, doesn't do the justice for the work that community is doing at this project at this point. So I have decided that Robin will be housed under an organization, not just an individual entity. The organizations will be called Sparkles. Okay, so if you want to have a look at that, just go to github.com/sparkles. It's spelled like this, and you can read more about it here. So as a future roadmap, we'd like to improve our performance for Robin, have some automatic document generation, runtime data validation for sure. And there's this feature that I have been talking about with. It's called auto const request optimization, where the developers won't have to worry about specifying the const flag. Have some ORM supports like Prisma, have authentication defaults. This will be there in the next week. Improve WebSockets. I made a PI yesterday, so maybe in the next week too. And transition the repo to the big organization called Sparkles. And most importantly, improve the documentation. I believe that a framework is only as good as the documentation available around it. And we have been actively putting effort to improve the documentation. So create some video-based documentation, more text-based examples, and add some support. So I believe that the 2023 is the year of AI, and have some GPT-4 based response from the framework or the framework documentation page would be nice. But humans, I believe we are still working for humans, and human documentation cannot be replaced. So at this point, I would ask you to join our community and have a link show up right here. Yay! So, no, too bad. So, start Robin on GitHub, I guess, if the slides show up. Otherwise, you can, yes, star Robin on GitHub, and you can ask me any questions that you may have. Thank you so much.
Thank you so much for the presentation. I have a couple of questions on Slido. So first question that got one vote. Hi, I was on your talk in Geodata Basel 2022. I tested it. It was not possible to use middleware, etc. Can you tell us important improvements since June 2022?
Oh, there have been substantial improvements for the middlewares. We basically rewrote the middleware architecture from June 22. So try one more time and let me know how you find it.
So try one more time. Yeah, many improvements since then.
Yeah.
Okay, another question. Does Robin support background tasks like Fast API?
Robin has application events, but I haven't backgrounded anything at this point. So I'd like to say no. But if that's something that the community wants, we can easily add it in the future.
Okay, and final question. Great work, thank you. Is process management available? If a process crashes, is there info about this? How stable is the GraphQL implementation?
Process management is available, so if a process crashes, you'd get a stack trace. And GraphQL is, I would say, still, like you can develop a GraphQL application, but I wouldn't suggest you to have anything in production with GraphQL and Robin integration. Because Strawberry had some changes recently, and we need to incorporate that into Robin. Yep.
Let's see if there is any other. No, that's all.
Perfect.
Thank you very much, Sanskar.
Thank you so much.
There are still a few seats available at the front rows. So thank you for joining after the amazing Samantha Cristoforetti talk. And I want I'm happy to present you Ivars Kalvanas, talking about pessimism, optimism, realism in the Django database concurrency. Big round of applause.
Okay, so let's start. First, why I picked this topic. So I used to work for a long time at a company called Tieto Every. So I was working on payment card software that is processing your payment card transactions. I did a lot of things there. So one of those things was that I developed an accounting system that, so in C++ and SQL, and that was handling hundreds and thousands of business transactions per second. So in these, so we did the official benchmarks. We went more than 5,000 per second, real card transactions, and only a smart part of that was this accounting system. And we did this all with a regular database, so it was Oracle, but I mean it's still a general purpose database. So we didn't have to use any key value stores. We didn't have to use NoSQL, like web scale databases or specialized databases like Tiger Beetle DB. So of course, there were unsuccessful approaches to this problem, but finally we refined it and we found what works. And so I know a thing or two about database concurrency. So now I work in a completely different company with which is doing which is fintech, and it's doing most of the code in Python, which is really nice thing for fintechs because most of fintechs use Java or some exotic languages. And we are using ORM primarily. So I have used SQL for most of my life, and now I'm trying to achieve things I was doing in SQL using ORM. And so that's why we have this talk. So let's first start with a simple account transfer. So what it does, it checks if the account has sufficient balance. Then it debits the account. It means that it reduces the account balance. And then it credits another account, so increases balance by the same amount. So of course, in practice, the code looks is more complicated. So my only reason for going this simple was to fit this code on the slide. So this is Python code. If this popped up in the code review, so I might have some complaints, but I mean, mostly it looks fine. However, if somewhere in our code we are using threads, so I have to start think about other factors for this function. So I see that this from account and to account come from the outside. It means that those could be modified by some other threads, and I must take care of concurrency issues. So where are those concurrency issues? So there is a race condition. So it's a classical time of check to time to use. So we check the balance that is sufficient to withdraw the amount, and only later we decrease the balance. And between those two steps, some other thread might do the same. And as a result, the account would go into negative balance. So this is a thing that we want to avoid. Another thing that is not so visible, there is also a possibility of lost updates on those lines that decrement or increment the balance. And you might ask, why is it so? Well, it turns out that in Python, those lines are actually not atomic operations. If you go into the bytecode, so bytecode has two parts. So in one bytecode, it loads the current value of balance, then it does the increment of the balance, and then it stores it back. So in between reading and writing the balance, some other thread, again, might do the same, and so we lose an update to this account balance. So how do we solve this? So this is something called shared memory concurrency. So the idea is that there are multiple threads and all of them try to access and modify the same memory. And if you Google for the kind of how to do multi-threading programming, and you will come up with a lot of search results. You will find about mutexes. Maybe you will find about fast user space mutexes. Then you have read-write locks, spin locks, latches typically in the database, then semaphores, which is a classical topic. Then you might find data structures that are meant only for single-threaded programs. Then there are data structures that are thread-safe. And then there are data structures that are thread-safe, and also they are lock-free, so they don't use any locking at all. Then there are atomic operations and kind of more complicated atomic operations like compare and swap, and approaches like read, copy, update. And finally, we have like approaches how to structure the program by using actors and not sharing memory at all. So there are a lot of topics. Of course, since we are in Python, and Python is so bad at multi-threading, we usually forgot about a lot of these kind of topics. But even Python has locks, so how to fix the code using locks. So we simply add a lock to each account, and then we ensure that both of these accounts are locked, and then this code is safe. Of course, we have to ensure that nobody else, no other function ever modifies the account balance without using a lock. And we also have to ensure that there's a specific order in which we acquire those locks so that we don't run into deadlocks. But so this can be all solved, and kind of this is a safe code. But yeah, so most of the code isn't like that. So most applications have kind of this generic architecture. So we have several front ends. Those might be browser instances talking to several backend instances. And finally, they all talk to the database that is shared between them. And so for some reason, when we start writing database code, even using Django, we forget about the all locking at all. So kind of we read these accounts from the database, we perform the checks, we perform the updates, we store the result, and then kind of we treat the database as a black box, and we somehow silently hope that it will work it out fine and no problems will happen. But it's, of course, it's not true. So, and in practice, so it might be that in 95% of cases you don't experience any problems, but when you experience those problems, they are typically really hard and might even bring your company down. There's one case that is kind of publicly available, but of course, a lot of companies have this issue, but just they don't go public with it. So there was a Bitcoin exchange that basically didn't do locking between time of check to time to use, and so the balance was kind of the available amount was overspent, and they went bankrupt due to this. So, how do we solve this? So there's I call this shared database concurrency, just to kind of share memory concurrency to shared database concurrency. So we have the same situation that we have several programs that all communicate with each other, but this time they do it through a database that is shared. And just to make things worse, so those programs are not actually using the data itself. So the record itself lives in the database, and what programs have is a kind of copy of that record that somehow is linked to the database. And what we try to do, we kind of try to refresh it, and then we try to store the updates and hope that this will lead to consistency. So if you try to find out how can you fix these concurrency issues, you can usually find pessimistic locking and optimistic locking. So those are the two major things. So just two topics about database concurrency and like two options what you can do. Of course, there are some resources that say, well, just use Redis for locking. And this is approach where a lot of people are not sure how the database works. And like, just to be sure, let's do another lock in the Redis database, and that should solve our issue. But here I want to look into those pessimistic locking and optimistic locking just to show how this can be solved from the database point of view. So how to solve it in the database? Let's start with the pessimistic locking. So there are two important things. So first you have to start an atomic transaction. So instead of going into this auto commit mode, you start a transaction that contains multiple operations, and then you have to do select for update. So you log the record in the database, and then you, using the same operation, you also retrieve the current state from the database. So this doesn't look so good in this kind of with a function signature that we have. So preferably, it would be better if you loaded those database objects just once, but let's just go with it so that you refresh the values from the database and acquire locks, then you perform all the checks, and then you save it. So this is kind of what we did in the Python code, so by using locks. So, but somehow the pessimistic locking, the word pessimistic sounds bad to me. So it implies that something bad is happening. So optimistic locking, on the other hand, sounds much more, much better. So what is optimistic locking? So the essence of optimistic locking is that it ensures that the row in the database hasn't been changed since we last read it. So how do they achieve it is that typically models have a new field called version, so which might be a number, or it might be a timestamp like the last timestamp when the object was changed. I've seen implementations that calculate a checksum of all the fields, which is also okay. And then, so this version is used to ensure that the row hasn't been changed. And then the important part of it is that it does retries. So it might be that some process already changed the row. So we have to retry until our update succeeds. And then there's this strange situation in Django. So if you are used to programming in Java, then this popular Hibernate project, it actually has optimistic locking built in. You just say that this field is a version field, and then Hibernate does everything for you. In case of Django, you have to install some kind of package or build something on your own. So there are three popular packages that do optimistic locking in a different ways, as I will show further. And what bothers me a bit is that some of them claim that they avoid database level locking. So keep that in mind. I will address it later. So how to do optimistic locking? So this is one of approaches by using select for update. So this is pretty much similar to the pessimistic locking, but there are kind of main differences is that, number one, we can do the check of balance while we are not kind of locking the row. And once everything is good, just before updating the record, we do the following. So we lock a database record for the same primary key and for the version of data that we currently possess in memory. And if this lock succeeds, that means that nobody has changed the row, and we can proceed with updating the record. And during all updates, we have to also increment the version number, which is not so nice thing, because all places where you update the model, you have to remember that you have to increment this version number. Of course, the packages that you can download, those kind of can solve this for you. Then the second approach is kind of doing optimistic locking using update. And so this approach is a bit more interesting because you don't have to work with models at all. So what you need is the primary key and the version number. And so what you do is that you filter accounts using this primary key and version. So if this record hasn't been modified in the database, you get the record, so it's one, and then you do the update itself, so you decrement the balance and you increase the version number. So the downside, of course, is that since you are not using models, then Django signals do not work, and if you have some auditing packages that rely on those Django signals, then you won't see those modifications. So, but does it really avoid the database locking? So we can quickly fire up Django shell. We set the auto commit to false, and we try to do this update, just as in the previous example. So it succeeds in the first session. When we try to do it in the second session, so what we get is that this update is actually blocked. So it doesn't return any result. It actually is hanging there. And it's hanging there until I perform the commit in the first session. So it means that actually some kind of lock is happening there, and we were blocked by waiting on the row. So the point is, database is always doing some locking, and that's a good thing because database should ensure that the records are consistent. And instead of like optimistic and pessimistic locking, I like to think about it like explicit locking and implicit locking. So for explicit locking, when I request the locking, there's this our select for update that will block and wait for locks to be released. There are some other approaches, so I will not go into this because of lack of time. But so there's actually implicit locking that is happening as well. So every update will place a lock inside the database. Every delete will place a lock in the database. Even the creation of records will place a lock, and sometimes these create operations and then kind of save with force equals insert might block when you are about to violate the unique constraint. And at least for the Oracle database, there are some extreme conditions when even query set, kind of like a select, might be blocked in some specific scenarios. So blocking is happening all the time. And what I want to show is that there's a blocking on create. So you can create an account with unique key 42. Then you try to do the same from other session, and it's stuck there. It's waiting for a lock. And if you commit, you get an error in the second session, which is fine. If you do the rollback in the first session, then the second session succeeds. So that's an interesting thing. So locking and blocking is happening all the time. On each operation in database is doing some locking. And it's not possible to avoid locks when you are working with the database. And this often leads to performance issues where you see that you are trying to go as fast as you can, but your database isn't consuming the full CPU or disks fully. Your application isn't 100% loaded. The network is not busy, but somehow the application is really slow. And the typical reason for that is that you experience some locking and blocking issues in the database, and it takes typically a DBA to show you where it's happening. So, but how to avoid this? So we know from a kind of Python programming language and programming in general that to improve concurrency, you have to increase log granularity. So you shouldn't have a one global interpreter lock. Instead, you should have multiple smaller locks so that multiple threads can proceed with work without waiting on the lock. So in the database, you typically get a lock on a row if you have a normal database. And well, sometimes you can break down your model to create separate models just to get more rows and to kind of increase the granularity of locks. And then the other tip for improving concurrency is holding locks for as short duration as possible. That's clear in the programming language, but what to do in case of database. So when are the locks released in the database? This is actually from Oracle database because it has this nice phrase. So it says that raw locks are held until the transaction either commits or rolls back. So we acquire locks by each update operation, and we release them only when we commit. And the other nice thing here is that it lists that these specific raw locks, TX locks, are taken by insert, update, delete, merge, and select for update. So there is no difference at the database level for these locks. They are all the same. They are all similar locks. So the idea is to reduce the time between updates and updates that take the locks and between commit. How to do that? So I like this example because it kind of breaks your logic as a programmer. So first we debit account, then we credit it, and then we write an entry that we actually did the operation. And the first update already takes a lock, and those are released when this transaction block ends. So how can we improve it? Since we are working with databases, we actually can move those creation of objects up. So by that, we reduce the time that is spent holding the locks, and still from the outside observer, the result will be the same. So either there are all of these records, or the transaction is rolled back, so it won't see journal entry without seeing the actual updates on the accounts. So there are many ways how to do it. So the idea is to move all the operations outside the critical path. And one thing to remember is that even if you have kind of rows that look the same, not all of them are equal. Some of them might represent your account, which might get like 10 updates per day. And then there are bank accounts which get million updates per day. So then what I would do is then try to update the bank account last, because more transactions are waiting on those specific logs than on my personal account. And then one more last thing. So there's this, how this version number is incremented. So I showed you this approach, which roughly in my mind translates to this SQL, and you can see this SQL also if you look at the Django executed SQL statements. However, when I was taught optimistic locking at the database level, we typically did something like that. So we took version and we assigned it value version equals +1, which is roughly something like this, like f expression in Django. But now the question is, how does it work? Because we have several steps. So we first have to read the version number, then we have to increment it, and then we have store back. How do we not run into lost update issues? And so we have this code. It could be running from thousands of threads in parallel, and the result would be still the same. So the key to this is how the update works. So first, it filters the rows according to where clause. Then it locks all of the rows, and only then it evaluates this set clause. So it reads the current version number only when it's already holding the lock. So in Python code, this is roughly equivalent to this code. So we hold the lock while we increment it. And so with that in mind, that we kind of, if we do not care about the order of operations, how those are applied, and because this variable is always locked, then we can do simple addition and even adding negative numbers to achieve subtraction. We can do that all without explicitly locking the rows. So that could be, we can count clicks or likes and so on, or retweets, and it's also the same for account balances. So all those individual operations, if we use the current value stored in the database, those will be correct. So how to do transfer without optimistic or pessimistic locking and still have a correct result? So we do something similar to optimistic locking, but the condition for there is not on the version, but we select account if it has sufficient balance. If it doesn't have, the number of rows updated will be 0, and we will raise an exception. If the account has sufficient balance, we reduce the balance by the amount, and we are good to go. And for the account where we just credit, where we increment the amount, we do not have to check it at all. We can just increment it, and it will be completely fine at the database level and completely correct. So, main takeaways. So remember that database always locks rows, and it might lead to blocking. So, and if you keep that in mind, and instead of treating database like a black box, you think that, oh, I'm doing update here, it will take a lock, and someone else will be waiting for the lock, for that lock, so I must release it as soon as possible. You will get a more performant code. And yeah, the other thing, kind of, if you start thinking about locking in the database, oftentimes you can avoid using Redis, which is kind of a common pattern. And Redis has other uses, but I mean, for locking, maybe it's safer just to stay with the database. So that's all. Am I on time?
Thank you so much. Yeah, perfectly on time. Thank you so much. You already have one question from Slido. If you have more, please write on a Slido. And how do you test that everything works in the different approaches? There is approach to test with PyTest or unit test.
Well, no. So I haven't done that in Python. So my experience was when I was doing like C++ and SQL. So we were running specially designed concurrent tests. So we had programs that were incrementing. So if we launched, let's say, 100 processes that each increments it by 1,000,000, we know that the end result should be like that. And also, since we write those journal entries for each account, so we can compare the end balance of the account to the entries that are actually inserted in the journal. So that's typical accounting trick.
Okay, thank you. Any more question?
Thank you for talk. It's great. If can I found hidden thread to block database if I use manually transaction stop and after that transaction commit? Can I probably, if code breaks in this moment, it can be causa to block row in database? Can it be?
And what happens to the process itself? It crashes? Or?
Yeah, it's crashed.
Yeah, so typically in that case, the database session will be rolled back. So there might be session timeouts. So database will clean it up. Yeah, sometimes it might be that if you crash in the process and database doesn't know that your process has crashed, it might wait for some time. So that's typically we set a couple of seconds, like transaction, it's session timeout. So once we start the transaction, it gets a couple of seconds to complete. But yeah, it happens that rows might be blocked. So what we were using also two-phase commit. And in those cases, yeah, it was typical that processes were blocked for a long time. And sometimes a DBA had to come in and remove a couple of records just to proceed.
Thank you so much. Big round of applause again. On Slido during the talk, and I will read the question after in the QA session. The Slido link is in a schedule.
Cosa a posto? Sì, sì, tutto a posto, abbiamo recuperato il ritardo e ora siamo allineati con il resto dello schema.
Ok, ci mancano ancora 3 minuti.
Sì, sì, sì.
Ok.
Talking about needing to how to unscriptalize your application. Big round of applause for him.
Thank you. Because we're in 2023 and we have to talk about AI in all of our talks, apparently, I tried to ask DALL-E what a developer replacing a SQL database with MongoDB looks like. It looks like that. So something, I like the fact that it draws like mobo blue, which is kind of how I felt the first time I've used MongoDB. So in this talk today, I'm hoping to help you understand a little bit more about document databases, how they work, and how to help you to change your mindset from a relational database to something like a document database. So it won't be mobo blue blue. All right, so hi, my name is Joel. I work as a developer advocate at MongoDB. Everything I'll be talking about today, obviously I'll be using MongoDB as an example. This should all apply to pretty much every document database that are available on the market, though. I am based in lovely Ottawa, Canada. I'm actually French-Canadian, so that's the charming little accent that you might hear. If you ever want to get in touch with me, Twitter, when they're not evil, is kind of a good way to reach me. LinkedIn also works, whatever. Feel free to reach me. I'm always open, always happy to answer any questions you might have. So what are we going to talk about today? Just so you still have like a minute to leave the room if you want to. I'll cover kind of NoSQL, what it is, but very, very quickly, I'll jump right into document databases. And I'll talk about understanding how relational data works in a document database. A lot of the things I hear all the time is, oh, I can't use a document database because my data is relational. We're going to cover that. Talk a little bit about how to do your schema designs, maybe touch on advanced patterns, but time is very limited. And then data modeling tips and tricks. And then we'll see how to migrate. So what's a NoSQL? NoSQL are just a bunch of new sorts of databases that came out to be more web scale. I was kind of expecting the comment at some point. Somebody did it earlier. So just different types of way to think about your data. There's a lot of different NoSQL databases out there. Key value databases such as Redis is a good one. White column stores, graph databases are a very interesting way to think about data, which is more about relation than the actual data. But most importantly, not most importantly, but I'm going to specifically talk about document databases today. So what's a document database? Well, it's just a different type of database, a different way to store your data in a database. In short, it works pretty much just like you would expect for any other database. And the terminology is very similar. So you can see here, like a database is a database. There's a few differences when we talk about tables in SQL. We're talking about those map to collections in the document database. And when we talk about rows in a table, those maps to documents, hence the name document databases. But everything else is pretty much the same. You've got indexes, you've got views, you've got transactions, all the things that you would come to expect from your typical relational database. So the document database looks a little bit like this. Basically, you store documents. You can think of those documents as being JSON object. Truth is, they are not JSON object. They're actually BSON. You can see in this example of a document, there's a lot of interesting things here. We've got an ID field, which is mandatory. And it's a field of type object ID. So you can see it's object ID, and then there's this huge number in it. So you've got some extended data types. It's not just numbers, booleans, and strings as it would be in a JSON object. You've also have a geodata in here. You've got arrays of documents. You've got a bunch of different things going on into this document. So that's really the power of document databases. So you can think of document databases as just an evolution of your traditional relational databases. It's just a different way to think about how you map your data, which modern technology allows you to do, which wasn't possible in the 1970s when SQL came out. So really, you need to change a little bit how you think about your data in order to use it correctly. Back in my days, as you can see from my gray hair, data was modeled independently of queries. So when we were using SQL, actually not just in my days, still the way we do it most of the time, if we take a look at this application, for example, this is a recipe book site that I'm going to put up. It's going to be very popular. I'm going to have like gazillions of people coming in to see this very famous recipe. And if you're looking at it from a traditional way of thinking about data, you immediately see this, right? Immediately you saw it was relatively simple. You saw there's ingredients, many-to-many relationship, instructions, one-to-many. Everything makes sense, and we're used to that. And it comes in naturally because we've been doing that for a long time. When we think about document databases, it's slightly different. Now you need to design a schema that works for your application rather than for the database. So what does that mean? Well, let's take a look at this example again. Let's take a look at this recipe book, this web page in particular. And let's look at the first part. The top part is maybe a little bit more obvious, right? We've got, well, the name of the recipe, the number of servings, preparation time. And if we think in our SQL database, we've got our table, which has the recipes and has the name, the servings, and all that information, so nothing too scary there. In a document database, we do the same thing. We've just got a bunch of key values in our document that list the same properties. So far, so good. Nothing strange in here. All right, so let's take a look at another part of this. Let's skip the ingredients for now and skip right at the bottom for the instructions part. So in our traditional SQL database, we've got a second table, and we've got all of the instructions. They map to recipe ID that maps to that other table there. And we'll do a join to get all of that information together. So in our document database, we'll think of it slightly differently. We'll just put in an array of strings. And that works great, because all of those instructions are specific to that recipe. You're never going to reuse any of those instructions in another recipe. So it makes sense to have everything together into one single document. So now you can retrieve that document, use it directly on your web page. All right, let's go into a little bit more complex, and let's take a look at those ingredients now. So for ingredients in a traditional database, you've got another table with all of your ingredients, your join tables for your many relationship. Actually, measurements should go in their own table as well. So now you end up with a bunch of tables. We've got this super weird table which has just a bunch of IDs in it, which if you try to look at it on its own makes absolutely no sense. So you really need to join that data in order to make sense of it. In your document database, nothing prevents you from creating this array again. This time it's an array of ingredients. Each one of our ingredients are there with the quantity and the unit. Right there. Now I know what you're thinking. Duplication, inconsistent data. All right, so what are we gonna do about it? Well, let's look at a few different things. Let's look at consistency. That's the first thing that spooked me out when I saw that the first time. I was like, oh no, some people are gonna capitalize all the ingredients, others are gonna use lowercase and ugh. Truth is, you always use a drop down for this type of input in your application. It's not like you're gonna do a free type form, whether you're using a SQL database or not. So what you would do with SQL is that you do that select star from ingredients, you populate that drop down, have the value, which is the ID of the field, and then the value displayed there. So what you'll do with your relational database is that you'll put all those ingredients in their own collection. You'll do exactly the same thing. You'll do that select star from ingredients or the equivalent, but instead of putting a value, you'll just putting the actual name of the ingredient. So this time, you're still ensuring that the data will still be consistent. It will always pick mushroom spelled that way with a capital M, and you won't end up having all kind of weird things in your database. All right, so that works. So you've got your collection of ingredients now. You can do the same thing for, talked about that, you can do the same thing for your measurements as well. So you can, what's actually very cool about it is that you can also add and mix a bunch of different things into that same collection because it's just a collection that you use to populate your dropdowns. So instead, what you'll do is that you'll create an index on the type. So you'll say, hey, give me all of the ingredients or give me all of the measurements from that collection. And it's very quick because now you've got that index built in and it just returns everything very quickly. And now you can have one function to always get stuff from that specific collection. So you can do that fine to get those specific items as I'm doing right here. And you can do the same for your measurements. All right, but there's still that issue of duplication, which, again, the first time I saw that really spooked me out. I didn't want any duplication. I've learned in school that not to do that. I've learned that in the previous millennium, and I've always tried to avoid duplication. And why is that? Well, mainly because in the 1960s, an IBM 305 for 5 megabyte of data cost $3,200 per month to rent. And if we compare that to modern devices, which fit in your pocket, we have about 1 terabyte of data for about $55 US nowadays. So the reason for avoiding duplication is not as true as it was. But apart from that, there's another issue that comes along that. Fine, okay, we can duplicate, we can put more data in our database, but we still want to make sure that everything is consistent everywhere. So how do I make sure that if I want to change the name of that ingredient, that mushroom, I want it to change it to button mushroom instead. So I can do that update in my collection that helps me to populate those dropdowns. That's nice, but I still have all of those recipes that have that mushroom in there. So I need to update those as well. Well, to do that, you'll just do a second update. So whenever you do that update into your first collection for your ingredients, update the first one on the left at the top, you update your mushroom to button mushroom, and then you update all of the recipes that have the ingredient mushroom to be button mushroom now. So you do 2 updates. Fine. And a lot of people are like, oh, that's weird. Like now I have to do 2 updates. Well, yes, but before you had to do 2 reads and only 1 update. So you're just kind of switching the workload or the work that you do somewhere else. What we're doing in this case is that we're really optimizing for read. Now I'm gonna have, like I told you, gazillions of visitors on this website. So I want my database to be ready to serve all of those entries very quickly. I don't want to do that join and try to map those 2 tables. That's an expensive operation. So if I can avoid that and make sure that I can deliver much faster results, then it's okay if I need to do an update that takes a couple of extra milliseconds because I'm not gonna do that update very often. Chances that the names of the ingredient will probably be mostly stable across the life cycle of my recipe. So I'm really optimizing for read in this case. And that's what we mean by changing a schema based on your application. All right, but what's really cool now is that I've got this document, as I've shown you, and we've got all of our ingredients, all of our instructions. So now I can do items.find or recipes.find1 with the ID, and I retrieve the whole recipe. And I can just use that, put that on my web page, I'm done. Like there's no need for processing to rebuilding that object on my front end. Everything that I need, I just use directly on my web page. So much easier to use, much better developer experience as far as I'm concerned, which is one of the reasons why I like to use that. But also, again, we're optimizing for read. So we're making sure that we deliver very fast as the users read. And then we can accept a little bit slower operation on the update side by doing 2 different updates. We can do transactions to make sure that the updates are happening at the same time. There's a bunch of different things that you can do there. I know that's often a concern. There are ways, I'm not going to cover that today. I'm not going to go that deep, but yeah, there are ways to do that. Okay, so now there's one thing I wanted to add to my application. I want to add like profiles for the chefs, like all of the authors of the recipes. So I'll have this new page that'll list all of the recipes for, or all the socials and all that stuff for the authors. So what I'll need to do is that I'll need to have a collection for all of my authors on the left, and I still have my collection on the right, or my specific document for that recipe. And I want to specify that, oh, this recipe was created by a specific author. So there are ways to do joins in MongoDB. That's kind of a misconception. People think that you cannot join data. That's not true. You can still do those. But just before I get there, last time I gave this talk, someone's like, oh, wow, you jumped into aggregation pipeline. I have no idea what an aggregation pipeline is. So I'll take a little interlude despite me not having any time at all to deliver this whole talk. But aggregation pipelines are a way to do some very intense calculation or queries in MongoDB. So if you want to perform more complex operations than just a find one, by ID or find one on a specific criteria, you can use aggregation pipelines to build pipelines that will filter down to the result that you want. So basically, in this case, we've got an example where I've got all of my listings, and then I do a match operation, which will kind of filter down all of my records, pass it down to the next stage. The next stage is a group that will group all the information. So if you want to do something like, oh, give me all the recipes where the chef is from Canada, you'll use a bunch of aggregation stages to query that data in order to get that. So there's a lot of different stages that you can use. Match, group are very common, but the one I'm going to talk about specifically is $lookup. So back to our regular programming. Joining data. So how do you join data? Well, pretty much the exactly same way you would in a SQL database. So in my recipe document, I'll add an author field, which will have the value 1, which maps to the author number 1. Now what I want is to join those 2 data sets together. So what I'll do is that I'll do an aggregation pipeline, so recipes.aggregate. I use the $lookup stage, and I say map the author ID 1, and just fill that as part of my document being as the author data field. So now my document on the right looks a little bit like this. I now have all of the author data as part of it. All right, we've got a little bit of time for one advanced pattern, one that I really like. Because that one, I think, when I'm looking at this, and I'm looking at my recipe book again, I want to have the author name on the page. So having to do that join kind of defeats the whole purpose of using MongoDB in the first place. So everything I've told you so far is like, hey, try to keep everything into a single document. But now I'm telling you, well, do that join to get the name of the author. So that is kind of a weird thing to do. So there's a fun little pattern that you can use when you're using MongoDB called the extended reference pattern. So instead of putting the author ID here, what I can do is put an author object, have the ID, but also have the name. So in this case, I can do or instead of doing my aggregation and the $lookup, I can just do items find 1, and then I retrieve all the data. And once again, I've got all the data ready to go. Everything is all the same place, and I can use that object directly into my web page. So once again, easy call, no joins. I get all of the data in here. But we still have that problem, right? We still have that duplication, that inconsistent data. What happens if I get married and I take my spouse's name? So we'll have the exact same problem that we had before, which can be solved by just adding an extra additional update. So we'll do that update to the author. We'll also do an update to all of the collections that have that author name. Again, even if that operation took few milliseconds, that's perfectly acceptable in this case, because again, we're optimizing for read in this case. All right, and then there's other tricks that you can do to do stuff like counting the records. Like in my profile page, I wanted to do like, oh, see all 5 recipes. Well, I can do that counting record using an aggregation pipeline, but now I'm doing 2 queries. So you could do something very similar. And whenever you insert a new entry into your recipes, you can use an aggregation stage. I'm talking about it because I removed like most of the slide about this section, except for those 2, so I kind of have to talk about it. But yeah, so you'll use an aggregation pipeline to make sure that the update will calculate the new total of recipes and then update that record at the same time. It made more sense with all the slides. So there's a lot of different advanced patterns, and that's one of the things that is very, very interesting and fun about document databases. Because they're so flexible, there's so many things that you can do with it. You can change the schema of your documents as you go. You can also enforce it, don't worry. But you can change it as you go and as you progress. And if you see that something is kind of slowing down because you have to do that additional query, well, you can start to use those patterns to make things much, much, much quicker. And again, you're just trying to group everything into one single read when it makes sense. So kind of a good way to think about it is that data access together should be stored together. It's kind of a thing that we say. It applies for reads mostly. So there's kind of that caveat, as you can see here. So there's that caveat here that this is mostly true for applications where you want it to be read optimized, such as the example. There are some other applications where you'll be write intensive. That'll be the case for IoT, for example, where you add a bunch of data and you'll have one person doing analytics once a day type of thing. You'll have to think about your data slightly differently. You want small documents, small insert, you want to use time series. So there's a lot of patterns that are meant specifically for that as well. All right, so I have some time for just a few tips and tricks when you start modeling your data when it comes to MongoDB or document databases. Try to favor embedding. That's always the number one. That's the big benefit of using the document databases. And when you start to use those embedded objects inside of your objects, then you can have more complete and you avoid some of the joint operations and it'll be faster. However, needing to access an object on its own is a good reason to do so. So in the example where I had the authors and the recipes, I still want to be able to access the entire author profile on its own to display it on a page. And it doesn't make sense to duplicate all of the social and all of the stuff of the author inside a recipe object, because then I'd probably need to update all of those often, and then it doesn't make sense. So sometimes you'll want to have those stored in their own collection and not embed them. So avoid joins or dollar lookups when you can, but don't be afraid to use them. If it provides a better schema, then it does, and just use them. There's nothing wrong with it. Another big thing, I haven't really talked about it, but arrays should never grow without bounds. So that's a very dangerous thing because you've got those arrays. Sometimes people will build those massive objects with an array, and they'll just put in stuff like they'll have an IoT sensor that'll just write something every second, and you've got a limit of 16 megabytes. Like, that's still a lot of data, but it doesn't mean you should be using all of those 16 megabytes, because then you run into a bunch of other issues. If you need to perform updates and things like those will take a lot of time. So if you can use arrays, don't over abuse them. When it makes sense, the instructions in a recipe, the number of ingredients, I know I'm never going to hit 16 megabytes of ingredients, or that's going to be a really complex recipe. So you can, those make sense for arrays. And most importantly, how you model your data really depends on your application's data access pattern. So really think about how you want to use your data and then model accordingly. So rather than just following a set of rules as you would in a SQL database, then just model it based on how you need that data in your application. All right, so if you want to migrate from a relational database to a document database, there's a couple of things that you need to keep in mind. First of all, it's hard. It's a hard process. So I'm not going to lie to you. If you want to do it, it's going to be a huge undertaking. It's not the most obvious thing, especially if it's your first experience with a document database. I'd probably recommend starting with a small greenfield project first. So it is hard, but it's not impossible. There are some success stories from Shutterfly, for example, that migrated like 20 terabytes of data from Oracle to MongoDB while they were still going up and running. So how did they do that? Well, basically, you'll start to do that first migration. You'll start to rewrite some of the logic in your application. And for a little while, you'll need to run 2 databases simultaneously. So you'll do one massive update with all of the, or one massive insert into your new database while keeping everything in sync. So that in sync, that's pretty sick. So you need to keep all of that stuff in sync, and that can be very challenging. So you'll need some mechanisms in place. We've got a lot of documentation that describes exactly how they did that. And there's a couple of good, interesting stories about that specifically. However, there's a product that is coming out, and I just love that new tool. So I like to talk about it. It's just called the Relational Migrator. And unfortunately, I don't have a good screenshot. It's still in alpha mode or preview mode. But basically, it lets you connect to your SQL database using your typical ODBC, and then you'll have all your layout, and you'll say like, oh, well, all of those instructions, I want them to be part of my recipe object now. And it will try to rebuild all of your schema in a document database, and you'll see how all of those fields are mapped to. And then you can just go click and start the sync, and it will start by doing exactly that. It'll do that massive insert, and then it will make sure that it keeps everything in sync. And now you'll have those 2 databases running, and you can start changing parts of your code to connect to your MongoDB instance until you're satisfied with all of the code being looking at the document database instead of MySQL or SQL. Whew. That was a lot of content. Like I had a 45-minute talk there. Let me catch my breath and do the recap. So we'll have 1 extra minute for questions. So quick recap of all the things we've covered. Document databases, it's basically JSON on steroid. So that's kind of a way to think of it. So just think of a JSON object stored in a database. I'll have a link with all of those. So I know that the text is very small, but you'll have the link to the slides in a minute. So relational data in documents. Yep, that's perfectly doable. Document databases, you can think of them just as an evolution of RDBMS. As far as schema design goes, design a schema that works for your application. That's really the number one thing that you need to think about. Couple of advanced patterns I've talked about, the computed very quickly, although I didn't have the slides, as well as the extended pattern. And a few tips and tricks. First of all, favor embedding whenever you can. If you need to access an object on its own, store it in a collection of its own. Avoid joins and lookups if you can, but still use them when it makes sense. Arrays should never grow without bounds, and how you model your data depends on your data access patterns. And finally, the migration considerations, and take incremental approaches. So start small, start by doing that first stop, and then change the code slowly but surely as you progress. So I have a couple of extra resources. I'll store everything in one single link at the end. If you're interested in knowing more about MongoDB, I know it's not here. It's not as nice and beautiful and pretty, but Milano, they're going to have a MongoDB day in a couple of months, so October 4 if you're interested. And I have this link with all of my slides, all the additional resources. QR code leads to the same place. And that is all I had. Thank you very much.
Thanks a lot. We have quite a few questions. I'm sure we cannot answer all of them right now, but I think Joel will be available to answer your questions.
I'll be available. I'll be around all day tomorrow.
And so one hot topic is how to track the schema changes and how to apply these migrations to the schema across a large database.
Yeah, there's a couple of different patterns that you can use. So the most common one is just a schema versioning. So basically, as part of your document, and that is logic on your application side, basically. But what you'll do is that you'll just add a versioning number in your documents, and then you'll know that, oh, this is a document from version 1, this is a document from version 2, and you'll have different logic in your application. Eventually, what you want to do is to make sure that you update all of your version 1 in order to only have version 2 so that you can clean up your code at some point. You don't want to keep like 20 different versions and have all of the logic for like if version 1, if version 2, if version 3. So you'll want to make sure to clean that up every now and then. But that's definitely a pattern that is commonly used for that.
And there are standards or formalization about how to describe the schema of this of your documents.
So no, there isn't any standard ways to do it, and that is probably the scariest thing, at least for me when I started with document databases, is that there's, like, it seems a little bit overwhelming. I used to write some code, and if it didn't work, and if it sucked, there was a DBA that would just come in and fix it for me. And now using a document database, I'm kind of responsible for my queries, which is kind of spooky. But there's no real standardized way to do it either. So you really have to adapt based on your document patterns and see how that goes. And if at some point your app, and that's kind of the whole idea, is that if your application changes and evolves in a way that, oh, all of a sudden now I need to do that additional query to count the number of recipes every time someone looks at a profile, and then I see that my database is getting a little bit slower, then I realize that I need to change my patterns a little bit and use like the computed pattern, for example. So that's kind of how you'll evolve throughout the life cycle of your application.
Thank you. And there are edge cases, or have you encountered edge cases where actually the relational approach works best than the document ones?
I am paid to say no. I mean, I think just like any other tool, it's always a matter of finding a tool that works for you. And I was lucky enough that when I joined MongoDB, of course, that's when I started using it a lot. But I had a couple of experiences before, and I had the opportunity to be able to try and play around with it and do a couple of mistakes. If you don't have that luxury and you need to deliver tomorrow, pick a tool that you're comfortable with. Like, don't start with something brand new that you know that there's some sort of learning curve in it. Like, it's much easier to pick like boring technologies from time to time. But I think ultimately, I think it's a tool that makes me more productive as a software developer. I think it provides me with different tools, and just makes more sense once you get into that mindset. It makes more sense to use the data in a more natural way.
And do we need to run multiple write on a transaction to solve duplication issues? I mean,
can you repeat the first part?
Reading as it's written, do we need to run multiple write on a transaction to solve duplication issues in the data? So when we run aggregations, etc.
Yeah, there are ways to, and that's too bad. I shouldn't have removed the slides. But in the computer pattern, I show how to do it in one single step using an aggregation pipeline. So you can do that read, do that count, and then do that write at the end. So there are ways to group multiple operations within by using aggregation pipelines.
And one last question, then the other you can do in person. How much time did it take to migrate 20 terabytes of data?
Good question. I don't know. I wasn't there. But I think there was a time thing. Oh, it didn't. But yeah, no, those are huge undertakings, and it's not something that you do over a weekend. That's for sure. So I'm not gonna lie. It takes some time, takes some work, but it's definitely possible.
Thank you so much.
Thank you very much.
Big round of applause. I'm sorry for the video issues.
Oh, that's fine.
The recording, actually, the recording is fine.
Okay. Okay.
who will talk us about graph machine learning on the cloud. Big round of applause, please.
Thank you. Thank you. Can you hear me fine? Yeah? Okay, great. So it's a pleasure to be here. Actually, the first time a speaker at PyCon. I must say that it's quite a moment. So hope you'll enjoy this wonderful talk. So I'm Alessandro Volpe. I work as a head of data science in BPEX Tech, which is a consulting company, a competence center inside this consulting company offering machine learning, cloud engineering, and lots of funny stuff to customers. And most importantly of all, I love graphs. Well, I forced myself to like graphs, because actually some time ago my wife decided to renovate the apartment, and so I thought to myself, amongst all the possible strategies to avoid doing anything in the house, what could I do? So I started studying graph machine learning. So I hope it was a good idea, but at least I'm here, so that's me actually trying to sell you some graph. And so I'd like to share a couple of things with you today. So some boring theory on what graphs are, and some interesting theory on how we can do actually machine learning with graphs, and finally some hopefully insightful stuff with what we can do with machine learning on the cloud. How many of you, just to know, work with graphs in Python? Few people by raise of hands. Okay, graph machine learning. Okay. This will be a, let's say, gentle introduction to graph machine learning, but of course, if you have questions, I'm available later. So all you need to know on graphs to understand this lecture, this talk is right on this slide. So a graph is a structure. It represents entities or objects which are actually called nodes or vertices. And these nodes might share relationships with one another. And these relationships are represented by edges or links that link or connect to nodes. And one easy example of what a graph could be is the airport hub. So you can imagine airports as points on the map, and those are the nodes, and the routes, the flights that connect the two airports are actually the links or the edges that connect it. And that's all you need to know, basically. I love graph. Python also loves graphs. So there are plenty of libraries that you can use in Python to define, to manipulate, to do analysis on graphs, and there are some over there. I will present some examples using NetworkX. And if you want to do some more, say, funny stuff, or you want to push a little bit further with some machine learning or deep learning on graphs, those are some popular, let's say, libraries to use. So Stellar Graph, Deep Graph Library, and Karate Club. So some Python code just to as an appetizer. So quite easy on NetworkX to define a graph. So you instantiate the object nx.graph, and you define a set of vertices with unique identifiers, and another set of tuples that represent the edges, so the connections between the nodes, Milan, Dublin, going back to the examples from before, and then method add nodes from, add edges from, and there you go. Okay, you have a graph. That's one way to represent it. There are other ways, of course. You can represent it as an adjacency. I cannot actually pronounce it. Adjacency matrix, which is a binary matrix in this case, where the ones are actually where the edges connect to nodes. There are plenty of different types of graphs, directed graphs, undirected graph, multigraph, multi-undirected graph, weighted graph, pseudograph. Do we care? No, because we're here for the machine learning on graphs, okay? So let's skip the boring theory part and let's go straight to the interesting part. So how do we do machine learning on graphs, okay? We can do some way the classic way around. So we can, let's say, start with a classical feature engineering process where we define some attributes related to our data structure. And imagine you are a I don't know, telecommunication company. You have the data set representing all your customers that communicate with each other, and you want to understand the probability that one of them accepts a promotion for an upselling of a service. Okay, what do? You can build a classification model, for example. And so, as a data scientist, you can define node attributes. So you associate with each one of your customers some features that describe them. So their age, their aging, so how long have they stayed with you as a company, the number of children, the color of the hair, every kind of thing your twisted data scientist mind can think of might be relevant to describe your customer. And then you also think that, well, my customers are in some way communicating with each other. So can it be that a person that is close to another is themselves inclined to accept an offer, and that feature actually is helpful to allow me to identify which customers are more inclined to accept my offer because they're friends or related with other people that are inclined to accept the offer. And so you start to define some local structural features. So, for example, you might want to understand how important that customer is, how many people is he talking to, how many people he is related to, but also with which customers he is communicating with. And so you start with Alice, and you see that it's really small, or Alex, which I can read, is speaking with Lisa. But Alex is also speaking with Anna, but it's not speaking with Tom, okay? Besides this, Alex is not speaking, is speaking with Anna. I totally forgot the names, but he's speaking with Anna, and Anna is speaking with Giacomo, okay? And Anna might not be that inclined to accept an offer, but Giacomo is. Okay, so what do? You define all the possible couples of relations that connect your Alice to all the other customers around. But this is actually unfeasible. It explodes exponentially. It's not doable, okay, in reality. And you're also bounded by the neighborhood that you're exploring, okay? You're going one relation over, two relations over, three relations over, and you lose actually manageability of this. What do? You need something else, okay, to actually represent the context of your customer, the context of the node of your graph. And these things are called embeddings. So the embeddings, this falls in the field of representation learning, which is actually trying to learn a mapping function that goes from the discrete domain of graphs to a continuous domain, which in some ways allows to represent graph by preserving the properties of the graph itself, so that if you apply it to nodes in a graph, they're mapped as points in a multidimensional space. You apply it to edges, same way around. They're mapped to points, to vectors in a multidimensional space. And you can do the same with graphs themselves. They become vectors in a multidimensional space, okay? Which is easy. But if I was 8 years old, okay, I would explain this as such. I take my graph, I have a funnel, I ship the graph into the funnel, I squeeze it, I compress it some way, and I obtain another thing that represents a compressed version of my graph under a different perspective. But I want to preserve the properties of the original objects. So nodes that are similar in some way in the original graph, so they are connected by the same edges, they are related in some way to one another, are mapped to points which are close to one another in another domain. Edges that connect the same network, the same sets of edges, are mapped as points close to one another, okay, similar to one another in another space. And the same with graphs. Graphs that are similar in structure with one another are mapped to points in another space. And this actually, what is tricky here is to define a kind of similarity, okay, so that the properties in the original domain are preserved in the target domain. And this paper here presents a really nice, let's say, taxonomy to describe the types of models that are that fall under the hat of unsupervised machine learning that do this kind of stuff. So they're divided in, according to this paper, shallow embeddings, autoencoders, graph neural networks. In all these examples, you have ways, okay, to create this embedding. And on this talk, just for the sake of simplicity and time, of course, I will focus on the skip-gram family of algorithms, and in particular, the node-to-vec. Okay, the node-to-vec works as such. So 4 steps. First, you take your graph. Done. Okay, easy, gratis. Okay, second step, you build the context around your nodes. Okay, so iteratively, you take each one of your nodes and you define random walks starting from that node. So what are random walks? Basically are sequences of nodes visited starting from the target node according to certain criteria that are defined in the algorithm itself. So you start from that node, and according to some probabilities, you visit another node, etc. And you create for each one of your node a set of random walks that represent the context around your node, because you visit other nodes starting from the original one. And you take this as your training set, and you pass it through, you use it to train a skip-gram model. Okay, so it's a shallow neural network, and you take the weight matrix in the hidden layer, and that weight matrix is actually what represents your embedding in the target domain, because the skip-gram model learns, okay, to rebuild the context of your original graph. How many of you work with natural language processing? Okay, how many of you work with the word2vec? Okay, you basically learned nothing new here, okay? Same stuff, same identical stuff. Your input graph is like your original text, okay? What's actually innovative in here is the process of generating random walks with represent your sentences basically on your text. And what you do is actually applying a word2vec algorithm to your sentences. And those actually map the words, which are your nodes in here, to a space where you can measure the similarity of words with cosine similarity. Okay, same stuff. And it's as easy as that. 3 lines of code besides the importing of the library. You define node2vec, you pass it the graph, define the number of dimensions you want your embedding to be. Typically, I think the default is 64, but you can use dimensionality reduction algorithms to actually represent those 64 dimensions to, for example, a b-dimensional space to actually see it, okay, to be able to graph it. You fit your model, and then you take your word vectors, and those are the embeddings, and there you go. Okay? Easy as that. Now, I promise to do this on the cloud, okay? So let's jump right into it. For the use case, I will be using a data set from Kaggle. Okay, the data set is a simulation of credit card transactions. And in this case, you can see the graph. In this case, the graph is called a heterogeneous graph because the nodes have different types. In this case, you have users, okay, which hold credit cards, and the other nodes are actually the merchants, so the shops where people spend their money in. And what the objective of the use case is actually to try to classify if a transaction is a fraud. A fraud for credit cards can be when someone of course, steals your credit card and spends money, of course, in your place, or someone hacks your account and does the same. So it's kind of difficult to prevent. So it's actually important to try to define ways to identify in a fast manner frauds, to be able to avoid, of course, well, to raise a dispute and avoid, of course, this kind of behavior. And for doing this, I'll be using a notebook that is actually running on Google Cloud Platform on Vertex AI. You know Vertex? How many of you, more or less? Okay, on Google Cloud. Cloud platform, public cloud platform, which offers a number of services for doing lots of stuff. Vertex AI is one of these, so it's an AI platform that simplifies and helps developers and data science and machine learning engineers to prototype and to put models in production and maintain the model in production with all the machine learning engineering pipeline. Okay, here I have a Jupyter notebook. I'm not connected to the internet, so we'll just bear. Oh, sorry, you cannot see it. Oops. Okay, let me zoom it a little bit. Can you read it? Okay. Yeah, I'm not connected to the internet. Sorry if it just pops up again. Okay. This is not funny. Wait. Because okay, I'll connect later. Importing some libraries just for fun. Then, most importantly, would I need cloud computing or Vertex AI to run this? Absolutely not. Okay. I could do many more stuff on Google Cloud, but I'll just do this for the sake of this presentation. So I'll read my data as a CSV. I'm downsampling the negative class just to be faster in all the execution of the code. And here you have your data set with all the transaction time, credit card number, merchant, category of the merchant, etc., with all your label in here in your data set, which is fraud, not fraud, of course, if the transaction is labeled as fraud. Okay, so it's not connecting to the internet. Sorry. Okay. Count the classes, more or less 1,000 credit cards, 700 merchants. We have a quite atypical situation in here. More or less 6,000 transactions are fraud, over 117,000, which is a huge number with respect to what it actually is in reality. Okay, in reality, it's much lower probability of finding a fraud. In here, so we are starting from a structured data set, and we wanted to convert it to a graph. So what we do, we define a function that returns a graph object from network X. We define this mapping function, which is a dictionary comprehension that runs through all the unique credit cards and merchant values and assigns a ID to each one of them. And we use them to define other columns, which are the from and to attributes, which define the direction in where the money flows from the credit card holder, hopefully, to the merchant. Okay. What we do then is grouping by from and to transaction and summing up all the frauds and the amounts spent on those transactions. And we define the fraud if at least one fraud happens between all the transactions between the credit card and the merchants. Then we create the graph starting from the edge list, okay, and then we set the attributes, okay, set the attribute time from and to, so defining credit card holders as label 1 and merchants as label 2, okay, flowing from 1 to 2. We also define the edge attributes, which are actually labels assigned to the edges, and in here the amount and the fraud of the amount of the transaction and the label fraud is actually assigned to the edge of the transactions. Okay, so also the edge carries information with it. We build it, okay, and it looks more or less like this. So starting credit card 0 spends money on merchant 14, 17, 58, etc., etc. Okay, so in this case, we check to if we did things correctly. So if the graph is bipartite, so if you can define two partitions, in this case, credit card holders and merchants, so that there's a partition where no edges go the other way around, only from credit cards to merchants. Okay, let's draw this. This in red are just the fraudulent activities, and you can see that there's a blue point which represents credit card holders, and the yellow point represents the merchant. Okay, so all the hopefully all the transactions connect two of those entities. Okay, down with the machine learning. Standard machine learning stuff. Okay, once we have the embedding, we have continuous vectors, and we apply whatever kind of machine learning algorithm we want. So we standard train test split. Okay, we select the edges based on their label. Okay, and we stratify the sampling based, of course, on the distribution, since it's an unbalanced problem, and then we rebuild the model starting from the subset of edges that we sampled in there. Okay, so we'll have a subgraph for training and subgraph for testing. Finally, time to run the node to vec. Okay, so we import the node to vec, but in this case we want to classify edges. Okay, not nodes. We want to see if an edge is a fraud. Okay, it's associated to a fraud, not actually nodes. So what we do is a simple trick. Well, actually, more than a trick, it's how the edge embedding is defined. We start from node embedding, and we apply those functions, which you can see as parameters in your pipeline training. Adamar, average, weighted, L1, L2 are those all transformations that are applied to the embedding on the nodes to define the embedding of the edges. And you use this to actually train your classifier. Okay, so I'm not optimizing anything here, which really gives me the chills, because as a data scientist, I would want to optimize stuff, but just for the sake of being fast, we just build a classifier with 100 estimators and the random state as obviously 42. Okay, we use the embedding that we are defining here to build a classifier on the training and testing on the test set. And what we get is actually, for the 4 different functions to calculate the embeddings on the edges, the ROC curve that appears to be satisfactory, at least, with this one here, the average embedder. Be careful, okay, because as I said, these ones you can see as parameters in your pipeline. So things can go wrong, and it can go wrong like this. Okay. Of course, there's something not working in here. Okay. and it works as such also in here. Okay, so you can see everything in the training of your parameters, all the of your algorithms, the training, parameters of the node2vec algorithm, which I didn't show, the parameters of your classifier, but also the functions for defining all the embeddings as hyperparameters. Okay, you can optimize over that with whatever method you prefer. You get your classifier, and you're good to go. Okay, great. Just for a conclusion, just for references, if you like, I promise a friend of mine to sponsor his book. He's quite a good writer, a bad person, but a good writer. Okay, graph machine learning, but also the other books are really fine. Okay, thank you very much.
Thank you so much. We have lots of questions, so I guess I think we will have time for 2 or 3 questions maximum, but I think Alessandro is more than available to answer the other question later. So what is the benefit of using graph ML over classical tabular ML for a binary classification problem, and more in general, what are the common use cases where graph machine learning is better suited than classical models?
Well, let's say that it came to an understanding that for some data the connections between entities are even more important, okay, than the entities themselves, okay, and the fact of having the possibility of having these relationships mapped and the availability of algorithms to exploit and to actually to represent those connections in such a way is actually an advantage that in some use cases might actually provide some benefits with respect to a classical machine learning algorithm. Classical applications, well, consider that most state-of-the-art recommendation systems rely on graph machine learning. Okay, they use particular graph neural networks to do the stuff, but other classical applications might be, for example, community detection, so finding groups of people that share something together. I worked for a company that used that to understand what kind of family a certain customer had, so to propose new offers for the family nucleus, okay? But also in biochemistry, you can use, for example, graph embedding to predict how a new molecule, okay, could look like for drug discovery and other kinds of applications, okay?
Thank you. And is it graph machine learning the state-of-the-art solution for fraud detection problem? Which advantages does it have autoencoders and N? Sorry.
Other?
Over autoencoders and N. But
it depends. Let's say that it's an approach, okay? Can be useful. Again, the connections between the entities is an advantage. There's a friend of mine in the audience who I spoke to yesterday, works in payments, and he told me actually that is very vertical in payments. Not always it's feasible to apply that kind of algorithm in, for example, for credit card issuers, because not always you see all the data about all the transactions that are actually performed. So can be useful. It depends on the use case. Okay.
And can we apply attention to graphs because the vocabulary might explode?
Sorry.
Can we apply attention to graphs?
Graph attention networks are a class of graph neural networks and say an evolution of graph convolutional networks, and they actually apply an attention layer. It's different kind of application. They, as you saw here, I was not considering any kind of attribute related to nodes, and besides those kinds of applications that I showed are so-called transductive, which means that it learns from the whole data set, and if you add another node, you need to retrain your whole algorithm as you would do with a word-to-vec algorithm. Besides, those kinds of classes of algorithms actually are inductive, so you can give them another node that they can provide a classification on those. And of course, they can be they're suitable also for accounting for the attributes of the node by well, performing a certain kind of aggregation of the information that is passed from the context of the node to the node itself. Okay, with a process.
Okay, time is over. Thank you so much, and please, a round of applause. And now there is the coffee break will open soon, and next the final keynote for the day.